Let's refresh that. We should be live. There we go. There we go. Fantastic. Hello, 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 hello. Welcome to the stream. I'm a little bit unwell today. Unfortunately, I woke up with a severe cold. I actually woke up super, super late. I woke up in the afternoon. And I woke up with a pretty bad cold in the sense that I have a. Also, wait, is that RGB on my mic? I had no idea. Yeah, I think so. Okay. Um, I woke up with a fairly bad cough. A cough, a sore throat, and just a little bit, not feeling too great kind of thing. So yeah, I think should be feeling a little bit better now. I have had a cough syrup, prepared myself a cup of green tea, had that. Um, I suppose I should be okay. That said, this will be a relatively shorter stream than usual. I think I will go on to maybe midnight, maybe a little bit earlier than that, because I do have to like sort of do a little bit of clean up around the house. Um, because I'm having friends come over tomorrow, and yeah, so I won't really have the time too much to do that tomorrow. I will still stream tomorrow. I'll find some time to do hopefully day 18's question. But I don't think we'll be solving both day 16 and day 17. We'll leave the stream title as is until we are done with both 16 and 17. It'll take us a little bit of time, but hopefully once we're done, we should be able to switch that over, do problem 18, problem 19. So potentially there's, for the next couple of days, it's gonna like spill over a little bit to the weekend, etc. But yeah, let's see what happens. Let's see what happens. We will solve them as they go along. For now, we can just continue with the question. What did we do last time, right? So we had this particular test which we wrote for extracting the packet type ID. So I still do remember the rules. The rules are as stated in this file. What's up, Time Lord? I have a little bit of cold. I'm just trying to speak a little bit less. Um, God knows I'm not going to succeed in that. I talk way too much, but yeah, I have a sore throat basically. So I woke up like with a really bad cold. So right now it's a lot better. My nose isn't blocked anymore, and for the most part, the cough seems to have subsided as well. But I still have a little bit of a sore throat, and yeah. So in meetings, I didn't really say anything today. I was just like, yeah, okay, and I hardly did any work either. I didn't really get anything done. But yeah, hopefully we should be able to crack this question. I'm aiming to complete day 16 at least today. Day 17, I guess we may or may not be able to do. Let me see. I haven't really tried solving. Like I haven't even seen day 17 since we were still in like day 16 part one. So yeah, what's up? What's up with you? Anyway, so let me just continue. What was the rules? What were the rules last time? So we have if type ID 4, it's a literal. If type ID is not equal to 4, it's an operator. For a literal, we basically have groups of 5 packets where you have a 4-bit group, which is I'll also solve something. Okay, good, 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 good. We have groups of 4 bits which form the payload. Each one prefaced by 1 bit, which says that there is another payload packet if it's one. Otherwise it says 0. I'll try writing Dijkstra. Okay, okay, that's day 15. I think like if you solve day 15, like that will be like I'm very interested in seeing like how you approach that question. Like specifically it's a very standard question, but at the same time, like I said, like I just find it odd that I'd never really thought about this in all the years that I've spent with puzzles and algorithms and stuff like that. Like I haven't seen a single person write Dijkstra's actually correctly. So yeah, it was just surprising to me. So do solve that. I'd like to discuss the solution. I think that'll be interesting. Type ID equals 4, type ID not equals 4, that's an operator, and this is basically going to have, this is the one that can have nested sort of subpackets, right? So if b equals 0, that means we have a length, which is the total, we have 15 bits indicating the total length of the subpacket bits, and if b equals 1, then we have the total number of subpackets, but we don't know the length, which seems a little bit concerning to me because we cannot tell where to start and end processing the subpackets, do we? Um, yeah, that'll be a little bit difficult. I'm planning on implementing this right now. What's that? Hmm, let me see. Oh, computer files video on Dijkstra's. Let's check this out. Let's check this out. Let me just pause the music. Mm.
So what have we got here then, Mike? Tell me.
Well, we have a strange graph drawn out on my page. A comment on a previous video asked about Dijkstra's shortest path. Now, I happen to have implemented Dijkstra's shortest path for one of the pieces of research I was doing a few years ago, so I thought
I
I'm
have
at
liked
least
this video, but I watched this
somewhat
years
placed
ago.
to give an opinion on it. So let's talk about Dijkstra's shortest path, what it is, where it's used, and so on. Path finding algorithms are obviously quite important. Right? We use them all the time on Google Maps or on our sat-nav system.
Yeah,
Right?
just
There was a
like
recent video on
1.5x
navigation
this.
and how it works, but of course that's only half the story. Finding out where you are exactly is the first part of the problem. You've got a
I
network and
mean,
lots of routers.
okay,
See
so
the
he's, yeah, I mean,
what a sat-nav does when you say these numbers represents how hard it is to get along that road. So you can't ones that's good, and you know you've got water. You could just do is just search all the way through. UK what it does is basically similar to a sort of brute force flood field
there
search
we go.
through this space.
This is like the, what's it called? The first, what's it called? The phenomenon, like the thing, the first 30% of the video is useless. I don't know. Wordsworth constant. There we go. The Wordsworth constant is the idea in 2011 meme that one can safely skip past the first 30% of any YouTube video without missing any important content. Yeah, that sounds about right.
But
He
does it in
starts
a kind
talking
of in
about
the order
the actual Dijkstra's algorithm over here.
that makes most sense based on how fast these roads are. So we'll check the quickest roads first. So to do Dijkstra, we need a few things. First of all, we obviously need our graph, right? And when we need some idea of how long the path is to, let's say, B, once we've calculated it, or something like that. So at the very beginning of our search, we have S. We are at S.
S for start, right?
S for start, yes. Which confused me because some of the other letters are just in order and then
You
these
can
two
call
aren't.
it
Anyway,
source
S
as
has a
well.
distance of 0, right? It costs me nothing to get to S because I'm already there. Everything else,
Source
I'll just put a couple out just to
and
show you. A, B,
destination.
and K have a distance of infinity because that basically says we haven't looked yet. We don't know how far. So for all we know, it might not be possible to get there, right? And finally, E is just the same, distance of infinity, but with a smiley face to say that we've made it, right? Now, this structure here that I'm going to create is called a priority queue. Each of these will have a distance, but they're ordered also by that distance. So the shortest one's at the top. That's important. And we'll do it as we go through. So let's start our search. We start at S, and we look through the neighbours of S. And we say, right, well, A, it cost me 7 to get to A, right? It's a bit of a pain. So we were at 0 distance, cost us 7, so now we're at 7, right? So A, I scrap my infinity, and I write 7, right? So A is 7. Okay? A is still the second shortest path currently because all the others are infinity. Yeah? B is 0 plus 2, so that's 2.
Okay.
So let's just put a 2 in there.
So
This
this is
is all even though
cool.
we haven't actually got to the end.
This is cool.
Yeah, you're just looking at numbers.
We can't
But
get
it
to
still
E
has the
without
same
having a look
problem.
through all of these junctions. So
All right. So I've already,
this is what we're doing.
I think I've already gotten enough. Like, so the thing is, again, this is cool as a concept, as an idea, and I don't know if he doesn't code later on. I'm just trying to figure out from the thumbnails. I don't think he does. I don't think he does because there's a difference when you do this in code, which is specifically this operation, right? How do you do this? How do you actually take this A from the priority queue and update its value to 7,
that we've made it, right? Now, this structure here that I'm going to create is called a priority
right?
queue. Each of these
That's
will
the
have a
problem.
distance, but they're ordered
That's
also
why
by
I
that
say that nobody does Dijkstra's properly.
distance. So
Because in an actual implementation, unless you go and implement your own sort of custom priority queue, I don't think any standard library out of the box lets you
the
do what
shortest
he's
one's at the
doing
top.
here.
That's important. And we'll do it as we go through. So let's start our search. We start at S,
Like you can't do this in Java, for instance. You can't do this in Java, for instance.
and
Like
we look
this
through the neighbours of
operation,
S.
I'll
And we
tell
say,
you
right,
which
well,
operation I'm
A,
talking
it
about.
cost me 7 to get to A, right? It's a bit of a pain. So we were at 0 distance, cost us 7, so now we're at 7, right? So A, I scrap my
This
infinity,
operation, right here.
and I write 7, right?
You
So A
can't
is
do
7.
this. You can't do this in most standard library implementations. You have to make your own, right? I'd use a heap and hash map together probably. Um, yes, sort of. Yes. That is part of the solution. But again, there is a little bit. Again, this is why I say not read the Advent of Code channel if you don't want to get spoiled on like what that sort of the fundamental reason that works is. But there is a thing, and it took me quite a while to arrive at. I don't know. It might seem obvious to you, but it took me quite a while to arrive at that. There is a little bit of insight in the sense that you can actually do something with what you've just mentioned, but you can do something which will make it such that you don't need to do this. What he's done here, right?
A is still the second
I don't want to spell that out because like
shortest
that'll
path
kind
currently
of
because all
spoil
the
it.
others are
But
infinity.
like
Yeah?
if you arrive at it independently, and of course, like as I said, it might seem obvious to you. It didn't seem obvious to me at all. It felt like it was like one of those things that seems like this is the crux of the data structure actually working. This is the thing that makes the data structure actually work, right? So I just feel like yeah, and again, the way I've implemented it is not the most efficient um in a certain sense. Um and again, I don't want to spoil anything over there because that can give you hints, but it's not the most efficient, but it is as close as you can get with standard library only in at least in Java, right? In Java/Kotlin, it is the most efficient you can get with using data structures from the standard library only, without using writing your own custom heap or your own custom data structure, because the actual data structure you're supposed to be using is something called a Fibonacci heap, which is not something that is present in almost any standard library, because Fibonacci heaps are slow on small sizes of inputs, like small numbers of inputs. I'm not awake enough today to do this. I think you should be. I think this question shouldn't be. I mean, it's just Dijkstra's. Again, the question literally, if you read the question, it's immediately obvious that it's just the implementation of shortest path, right? And the reason I took super long to do it was because I was trying to derive Dijkstra's on my own. At the end, I just gave up. Like, obviously, Edska Dijkstra, I have nothing on that man. So, that guy got it in some single afternoon while he was sipping tea or some shit. I've heard I don't know. I think it's an apocryphal tale. I don't know if it ever happened actually, but apparently he was just like out on the balcony or something sipping tea with his wife or some shit, and he it just struck, like the algorithm just struck him, and I don't know. But I'm not Edgar Dijkstra, so I can't really compete with that man. So I eventually looked up like the pseudocode, the algorithm, but I still had to get this sort of implementation inside to be able to do it. I didn't sleep yesterday. Welcome to the fucking club. Neither did I. I don't know what happened, dude. Like, what's happening? Like, I have two other friends who didn't sleep yesterday as well. Like, one of my friends was awake at 4 a.m. Another friend of mine in the US was also awake at unearthly times for him. I don't know what happened yesterday, but lots of people just haven't slept. I didn't sleep at all. I slept at 8 a.m. this morning. I slept at 8 a.m. this morning. I was not able to get sleep at all. I don't know why. I don't know what happened. I was just unable to sleep. What Squid Game? I don't know. I was just like I was reading a manhwa, and then I was like, okay, time to sleep now. And then I tried sleeping, and like 10 minutes later, I'm just not even drifting off. I'm completely awake, absolutely awake. And I was like this till like 7:30, 8 a.m., which is when I slept. I slept at 10 and woke up at 10:30. Wait, like half an hour? That's it? Oh my God. Okay, no, no, no. I slept at 8 and woke up at 3. I slept at 8 a.m. I woke up at 3 p.m. basically, 2:45 when I woke up. I was just stunned. I was like, huh, what? Like, it's like that point when you wake up so late that you aren't even alarmed by the time anymore. You're just like, fuck it. At that point, like you look at the time and it's so fucked up that you don't know what to think. I'm definitely not awake enough, okay? Yeah, I feel like Dijkstra's is like a little bit tricky in terms of like it is a fantastic algorithm though. It is a fantastic algorithm, but it hinges upon this mystical data structure that like obviously you can't do it, but I feel like the algorithm just it abstracts away like the pseudocode of the algorithm kind of abstracts away the actual complexity, which is having this data structure in the first place that lets you do this priority queue. You definitely need a priority queue for this question, by the way, because the inputs are large enough that if you don't use a priority queue, or like you don't use a heap, basically, right? Like, so if you just use like an array and scan it, which is the first attempt that I did, it works fine on the test input, but it runs forever on the actual input because it does a linear scan to find the smallest distance so far every single time, right? So it does a linear scan, and that takes too fucking long. Um, and yeah, that's the problem. So you do need a priority queue or a heap or whatever it is. Like, it's just priority queue is again just a um sort of a behavior, a particular type of behavior of a heap. The underlying data structure is obviously heap over there, but yeah, but you do need a heap in this case. But the important thing is a heap will not actually tell you. So heap to a hash map, yes, hash map, you can pass in the key, but the hash map will not give you the reference to where it is in the heap, because every time the heap is modified, which will happen anytime you may make an insertion or a pop, the references will change, and you cannot go and back modify the hash map for it, right? So you can't go and back modify the hash map for it. So that was one of the things I had thought as well, that I can use a heap and a hash map together, and I can make the hash map point to references in the heap, right? So I can essentially, the nodes that I put in there, I can make the nodes mutable. I can basically just, instead of val, I can write var, so that way I can actually change the value directly. But Java's hash map Java's priority queue has a problem where if you mutate a value inside it, the priority queue itself has no idea that you've mutated one of the values inside, right? It never gets notified. There's no way to notify the priority queue. That's the main problem. There is no API for notify or like to reheapify it or say that this particular element has been modified. You don't have a way of doing that. So immediately the priority queue is fucked up, right? So there's that, and there's also the fact that you can't maintain a reference to that specific, or in this case, like yeah, you can maintain a reference to a specific node, but if you were thinking about like getting around it by, like maybe removing and reinserting the element at that position in the heap, if you knew the position, that's also not possible because the position will keep changing whenever the heap gets modified. So both ways you have trouble, basically. Like you can't use the node reference, you can't use the position reference, you can't use anything, right? So you can't actually modify the priority queue in a way that that Mike Pound describes here. So that's kind of the problem. That's kind of the problem. So that's what I said. Like nobody implements it correctly. Everyone ends up doing a linear scan at some point of time, and for this algorithm, at least on my runtime, it doesn't work with a linear scan. Like on the Kotlin runtime running on my machine, which is really fast, it doesn't run at all. But even with my input, which I would say, as I said, is possibly the most optimized for running on Java/Kotlin. Of course, like you can do away with a few more micro optimizations in terms of like replacing objects with primitives and stuff like that. Maybe here and there, I don't fucking know. Again, I don't think Kotlin gives you any avenues for that, but if you're doing directly in Java, maybe you can shave off you know uh, like a couple hundred milliseconds here or there. That's possible, but for now, if I run day 15 test, it basically takes actually, I mean, let me just run this test first because like I haven't run the test before. It takes around 800 milliseconds to run, right? 600 to 800 milliseconds, somewhere around that range. So that's pretty good. That's pretty good. Squid Game was damn good. Okay, wait. Do you mean you watched all of Squid Game yesterday? Like by I watched Squid Game, you mean all of it, all episodes? That's crazy. That's a lot. That is a lot. Anyway, like if I run this day 15 test, let me just run the test. How long does it take? It should run fairly quick. Yeah, there we go. Yeah, it takes about a second. Actually, if I run the weird thing is if I run all the tests, then it takes a lot less than a second. So I think there's some initialization which gets hidden, gets kind of hidden within that, because if I run all the tests here, it actually takes measurably less than a second. So day 15, of course, day 16 test fails here. But as you can see, part 2 takes 982. If I rerun it, like sometimes it takes 600, sometimes it takes 800, 900, whatever it is. But yeah, 9 hours, that's the equivalent to 2 seasons of anime. Holy fuck. Okay, you're insane. You're nuts. Wait, how is that equivalent to 2 seasons of anime? 9 hours should be 1 hour is, oh yeah, 1 hour is 3 episodes, right? Approximately. Because 20 minutes per, so that's 3 episodes. 9 times 3, that's 27. Oh my fucking god, that's so much. Okay, yeah, yeah. Yeah, that is 2 seasons of anime, basically. 24 episodes because, like, it's not exactly 20 minutes per episode. It's going to be usually around 22. So, yeah, if you account for that, I suppose it'll be around, yeah, about exactly 2 seasons of anime. That's insane in a single night. Holy fuck. Yeah, that's a lot. That's a lot of watching. Okay. I have to watch Squid Game. If it's, yeah, I've gotten lots of recommendations for it, and considering my dad has watched it, I feel like I should. It becomes my moral obligation. I absolutely have to. Don't have a choice in that. Anyway, let's figure out how we can actually how we can um parse a literal, right? So identify, firstly, if we can identify a literal, that'll be good, right? So if we can identify a literal, that'll be nice. And if we can quick maths. I've seen all of FMAB in one sitting. It was 65 episodes. FMAB is not 65, it's 64 episodes. But whatever, it's close enough. I'm almost completely certain it's 64 episodes in one sitting. You are an actual insane person. You are an actual insane person. I've probably talked about this before. No, you haven't. At least not to my knowledge. I've never finished FMAB, by the way. I've gotten as far as episode 48. 48 out of 64. I had 12 episodes to go. Is that right? The math? 64 minus 12? No, that's not 12, is it? That's more than 12. 16? 16 episodes. Yes, maybe, perhaps. Yes, 16 episodes. Yeah, so I watched all but yeah, so I went as far as 48, and then after that I had exams. This was back when I was in college. I had examinations, and so I kind of stopped. and then I never got back to it ever again. So yeah, I do need to watch FMAB. In fact, I have a tab open. Full Metal Alchemist. There we go. It's open. I have an open tab for it, so I just haven't watched it. I did the same with 4 seasons of Sherlock. Oh wow, okay. Sherlock as well. Sherlock, I was actually pacing myself real well. I got as far as third season, second episode, I think. I was pacing it super well. Like I was watching in a very, very measured, very disciplined way because I didn't want to run out of content. And then I heard the final season, etc., is not that great, so I just kind of stopped. I never got around to it. Got never got around to watching it, but like the rest of it. But I got as far as I think episode 2 of season 3. I think that's how far I watched. I remember the end of season 2. It's the one with the cliffhanger. It's the crazy cliffhanger, and then like I watched till the end of season 2, and then I had to watch season 3. That was the only time I broke my discipline. Actually, that also took 24 hours. The trick to 24 hours watchathon is to start at 4 a.m. No, the trick to 24-hour watchathons is to be an insane person, to be a like actually certifiably mentally like a crackhead. That's the secret. That's what you need, bro. You have that. You have that skill. I'm afraid I don't. The trick to 24-hour watchathons is to start at 4 a.m., finish at 4 a.m. the next day and sleep. Yeah, I'm not even gonna dignify that with a response. Let's put it that way. Um, okay. So what do we need? Okay. Given a literal packet, extract the literal. Yeah, that's kind of what we want to do, right? So val packet equals day 6. So now what I feel like I want to do here is I kind of want to create a sealed class for this because like packet ID is nice, but I want to create like something which extends this for implementing um so packet um and can we do it as bytes string, and this gets the bytes. Okay, what's your problem? Make bytes private. What's your problem? Remove val from parameter. Oh, okay. Oh, that helps. Okay, okay, that's nice. Now what we want to do is okay, so is equal to day 16 dot literal packet giving in mm, all of this stuff, right? So this one's supposed to be literal, right? No, no, no. This is an operator packet. This is a literal packet 4, which means the packet is a literal value. Okay, yeah, that's this is a good example, right? And assert equals what is the literal in this case? Literal value which is 2021 packet dot get value, right? Let's create that. Okay, wait. Did I not extend literal packet? I did. Let's create literal packet dot get value member function extension member function literal packet get value int to do not implemented. Okay, cool. That sounds good. Right. So how do I want to implement this, right? So what's your problem now? Oh, seal types cannot be inst. Oh, I was not. Oh yeah, of course, right? I think that makes sense that a sealed class is always abstract because does that make sense? Oh yeah, that makes sense. Sealed class is always abstract. Okay. So in our case, like, are they literal or are they? The problem is, oh, in that case, I probably don't want to make it a sealed class. Do I just want it to be a normal open class? Uh, because I kind of wanted to. What's up, man? What's up, Mad Flash? How's it going? How's it going? How's it going? I just have like a little bit of a cold today, so I'm just trying to minimize how much I speak. Um, it's not expected to go well, but yeah, I have like a really sore throat. I was just trying to I had a Benadryl earlier, so I also probably won't think very well because I am kind of. Is it a bit thinky question? Well, yes, but actually no. Um, what I mean by that is it is a bit thingy question, but also I think this is a string manipulation question. I don't think it has as much to do with bits as you would expect. Like, as far as I can see, there is no bit manipulation per se. Maybe there is in part two, and I'm just like mm, being a moron, but as far as I can tell, we don't have like bit manipulation being like a serious problem here. Like I am choosing to like represent it as a string, and I'm proceeding that way because that seems to be a bit easier to me. Um, yeah. So like that seems to be a bit easier to me to kind of process it as a string. Like that's yeah, that's pretty much what I'm doing right now. I'm processing it as a string. So like I've just converted hex to this by creating this hex table, which very helpfully is already present here. So I could just copy paste it and just do some vertical text manipulation to make it a map. So that's a nice part, and I can kind of yeah. So I'm just making some nice little convenience methods, etc., to kind of help me with what I'm trying to do. So yeah, that's basically what I'm doing. So. Mm, the problem here is one of them is an operation packet and the other one is not. So when we create this, hmm, I probably want to call an invoker rather than calling the, yeah. Can I create an invoke at this point? Because like then how does it know whether I'm calling in, oh yeah, no. Invoke is on objects, right? No, but it could be on the companion object. Wait. So if I open companion object and do an invoke, on invoke, passing in a string. mm, oh yeah, no, this gets complicated, right? It's kind of like I have to get based on the packet ID. I have to make it either a literal packet or yeah, no, that's stupid then. No. If what I'm doing is dumb in that case, I shouldn't be doing this. I shouldn't be doing this. Let's just put get value inside packet. Let's just put get value inside packet. Let's do that, right? So let's remove all of this stuff. Let's remove literal packet. Let's not complicate things. We'll just keep it as a packet. Within this, we'll just put this packet, get value. Get value is of course not there. Let's create that as a member function, integer. Okay, and we are expecting, okay, so I should probably call this get literal value now because I don't have that class anymore. So get literal value. We are expecting this to be a literal, right? Let's leave that as to do not implemented because I just realized we will need something to validate if it's a literal in that case, right? So fun. Okay, so how we want to do that is given a literal packet. Mm, so I will sort of just copy paste this as another test given a literal packet. Um, is literal is true, right? So assert true packet dot is literal. Okay, and let's create that as a member property. Literal is equal to get packet ID for right. There we go. So we kind of want that to be the case. Cool, and that test should pass. Actually, I'll just set it as 5 just to make the test fail, or I'll set it as to do. It doesn't just to make the test fail, right? Let's see what happens, right? So is literal is true. Was the thing 4? 4 is a literal value. Yeah, okay. So type ID packet. Oh, it shouldn't be packet ID. Shift F6, get type ID. There we go. Right. Actually, can I convert these into properties? Convert function to properties. Uh, and we can probably just do that and convert. function big property, and we can remove the get keyword as well. So that way, what's your problem? Remove val from parameter. No, I do want bytes as a parameter. Uh, I what? How do you do that? Oh, but no, I do want bytes as a parameter because we will need that when we start solving the get literal value and all the other stuff. So we have to store it. We have to store it. I recognize it's not necessary right now, but it's fine. So if we do this, we run everything. Of course, they'll all fail because, oh, okay. So at this point, let me just do that. Let me just set this as 4. This should all pass now. Mm, no, it failed. Oh, sorry, wait. Version sum is 16. Why? Why did that fail? Input 1, assert equals, everybody equals 4, double equals 4. What? Why did that fail? Non-null parameter specified as non-null is null. Common utils dot invoke kt invoke. Oh, wait. What in Sam hell? Did I change something? Back? Maybe that's the problem? So this is not implemented. That's fine. The literal packet, I actually expect it to fail. What's your problem? Day 16, read file and process file name. X table of it. What? One of these doesn't match the hex table? That doesn't make any sense. It could be all of them. Huh? Which of these caused a problem? Okay, let's just do a println it and do that. Let's rerun. Which one fails? Wait, after 8, it's A. A is present. Oh, 8 itself fails. 8 is also present. Next table of it. It goes into common utils.invoke, right? Parameter this. Parameter specified as non-null is null. Why? What? I'm so confused. Let's debug this. I mean, I don't wanna. This is null. Oh, the hex table is null. Why? Why is the hex table null? Huh? Wait, I'm confused. Object is being. Oh, maybe that's why. Because it's not initialized yet, but it worked before. And it's working on the other things. Why is it failing only for this test? Oh, because we're calling the solver. Ah, that explains it. Let's move this to the companion object then. Let's move this to the companion object. Move to companion object. Explicit extension receiver won't be processed. X table of it. Uh, Continue. Explicit extension. Um, Remove that. Okay, let's try it now. That should be working, right? It shouldn't be a problem. Operation is not yet implemented. Get version sum. Oh, okay, yeah, version sum. Of course, of course. That's fine. That's fine. That's fine. That's as expected. That's as expected. All right, cool. That sounds good. It works though. Hmm. Uh, yeah. So both of these are okay. So we have a not implemented here. We have a not implemented here. Okay, cool. Let's do this. Right. So is literal. We want to make sure that it's a literal first, right? If is literal or if not is literal, then in that case we kind of want to throw mm, what's that? Illegal argument exception, maybe. Um, bytes. Uh, ID dollar type ID. Right. There we go. Cool. So that gives us um a thing. So we know it's a literal at this point. Jotaro, you've seen Jojo, right? Me? No, I have not. I have not seen Jojo, any of it. Mm, We have referenced it before, I guess. And oh, Verola Fox. How is she, by the way? It's been a long time. I haven't actually. Does she still code? I remember she was doing some of the JavaScript. Like she was learning JavaScript on, or I don't remember if it was JavaScript or TypeScript. Uh, on this one, Advent of not Advent of Code. Fuck, Free Code Camp. She's good. She left a job. Oh, I see. What was she working as? Like, I don't think she was working as a software engineer, right? She plans to transition into programming, if I remember correctly. Again, it's been a long time, so I'm misremembering a lot of stuff. But she got. Does she still code? Why would you ask such a question? No, no, no. Because it's like a lot of people. Again, like it's like when you kind of are a beginner and you are looking at. So a lot of people they kind of try to pick up software not because they enjoy it, but because it pays well or something. And I don't really know, like, because I've watched like one stream of hers, right? So I don't really know her well enough to know her motivations or like if this is something that she's sort of taking up seriously. So I was just wondering if like that's something that, she was doing as part of sort of a variety stream kind of thing, or whether it was like, she's genuinely actually going full on into software engineering, which I think is very admirable. But yeah, but it's just again being in the industry, I recognize that it's not for everyone, right? I wouldn't recommend everyone learn to code, right? I think it's important to know your way around a computer. It's important to know some things that make your life easier in the sense of learning scripts and learning just basic stuff that actually helps you work with your computer more and really understand what's going on, such that you don't really get you don't fall for stupid things on the internet and things like that. But I don't think it's important for everyone to know how to construct software or actually um, write real code, as it were, right? Like beyond scripts, essentially. I don't think that's like a thing in the same sense that I don't think everyone should learn how to build bridges or fucking manufacture automobiles or practically any other industry, right? Or perform surgery on humans. Like everything is useful to an extent, if you take the analogy far enough, but doesn't mean that you have to go and learn everything. So yeah, like a lot of people have this kind of view that everyone should know how to code, and I don't think that's true. Like I don't agree with that. I really don't agree with that. So yeah, so I was just asking because like I wasn't really sure with what mindset she was actually going into this. So if she intended to transition fully into software engineering, then yeah, that's very admirable. And it's difficult to step into the field. Um, especially after a few years like post college, etc., because again, it gets difficult to find a good job. It gets difficult to kind of step into the industry. And of all different sorts of engineering, I think this is the one which has the most amount of imposter syndrome, which is another really hard thing to deal with because you're constantly finding people who are very, very advanced, or like just in general, like very knowledgeable people who are able to run circles around you, basically, right? With what you're able to do. They are just aware of all. They can write software faster, better, cleaner, etc. That's one part of it. And you essentially you'll always find people who are better than you measurably, right? So that's kind of the thing in this field. Like it's very easy to get imposter syndrome as well. So it's just like it's a very big commitment, right, to kind of go into that. So yeah. um she got harassed at a workplace 7 years ago. She reported him and left. Ooh, oh my God. Okay. Yeah, it's yeah, it just sucks being a woman in almost any industry. Like it's just especially in tech. I feel like in tech it's like extra um it's extra problematic generally. But yeah, like there's just so many issues that they have to deal with. It's a rough life. It's tough. She is tough. She's still learning JS, does coding games, still makes projects. That's good. That's good. Looks like Stormy is projecting his own life. Uh, I mean, imposter syndrome, I would say that hasn't really affected me that much personally because I've always maintained certain skills that I know sort of set me apart from other people, right? But that said, yes, it's in a certain sense like I usually, when I compare myself to a lot of especially newer programmers, like it becomes a little bit difficult to maintain. Like it's just like at a certain point it's like, oh wow, I'm actually getting left behind, right? Left in the dust, that kind of thing. So yeah, that's difficult to work your way around. But always the part that helps for me is to recognize that I have certain skills that make me, while not precisely unique, like I don't think any skills, having any specific skills, makes it such a way that you'll have zero competition. It won't make you unique, but it will put you, like, it's important to have skills that will put you in the top 5 or 10% um, for that skill in your workplace or your environment or the people you work with, right? So certain skills, right? Like, so yeah, and I recognize those skills in myself. So I think that kind of helps. That kind of helps. But yeah, it's always important to identify what you're good at and really go all in that, like, in that direction. So I have imposter syndrome, I guess. Hmm. I mean, I don't know. It's like for a lot of people, it's hard to. It's just the test is basically like, do you have trouble approaching people at your workplace because you feel like they are smarter than you? That's essentially the test. That, do you feel that there are things that you cannot, that they can do, that you will never be able to do, right? That's kind of like having that sensation is really just imposter syndrome, and it kind of makes it hard for you to approach other people to ask them questions because you have a fear of feeling stupid, like of sounding stupid, right? So that's a big problem which generally needs to be overcome because um you know for most people, I wouldn't say this is for all people, but for most people who are not assholes, um how, like, the quality of your question doesn't really matter. Like, people, like, especially senior engineers, people who have a few years of experience and above, like, they should know, right, that the people who are new are going to ask questions that are very obvious to people with experience. But it's important to be able to, like, kind of turn back the time and put yourself in their shoes and identify, like, okay, when I was new, I didn't know these things either, right? And be helpful. And most people, I believe, like senior engineers, do that. So it's important as a junior to kind of get over that hump of, like, I don't know anything and I shouldn't be asking any of these questions, to just kind of cross that barrier. And once you cross that barrier, it kind of gets a lot easier for you because you are willing to ask for help when you need it, and people will always be willing to offer that help to you because you are asking for it. And you seem like an enthusiastic person, which is always a positive, right? So yeah, again, there are the exceptions. There are people who will uh get annoyed, etc. That's gonna happen. That's just the nature of people, right? Some people are always just gonna be assholes about the whole thing. So there's not much you can do about that. But yeah, in those cases, like, it's sort of like, That's when you have escalation channels and things. You speak to your manager, etc. Or if like lots of people are like that, you try and switch your firm, right? So sometimes people are just put in those kinds of situations by circumstance. They aren't actually assholes. It's just the situation, the environment that's making them that way, which is a possibility, right? So yeah, so that's just what you have to consider. So yeah. Mm, Rust suck, by the way. Oh, I mean, I don't know. I'm not I'm not gonna comment on Rust basically, but yeah, not gonna comment on Rust. Um, One thing, I have a feeling we might be approaching this a little bit wrong. Like I'm giving entire packets to it, and I'm getting going get literal value where it scans, gets literal, and does some stuff. But eventually, when we are parsing the entire message, right? The way I'm thinking about it, the way we are parsing, if we're parsing in the entire message, which basically looks like this and just goes on and on and on. Um, Comment on what was that? Just join the Thong Gang? Are you talking about Jan? I mean, yeah, I do watch his, I do catch his streams whenever he's when like whenever he's available and it kind of overlaps with the time when I watch Twitch. I don't really, I've turned off all notifications from Twitch, so I don't really know when people go live, to be honest. I've turned off notifications because I have way too many notifications coming in to me day over day all the time, and it really doesn't help. I get super distracted all the time by that, so yeah, it doesn't help often. Yeah, but I mean, again, I don't know where you're going with that one, but yeah, I will. Um, I do catch his streams whenever I can, if that's what you're talking about. I have no idea. Thong has a secondary meaning, and I'm assuming you're talking about the guy, um, you know, and not and not and not thongs, which I don't know. I just don't know where you're going with that, to be honest. But yeah. Um, okay, what is it? What is it? Okay. The way I'm thinking about it, if we have this full input, right? If we have this full input, we will need to know at every step of the parsing, where is the point where we start parsing and what's gonna be the point where we stop, right? I was talking about thongs you were. Oh, okay. How does that help? How does that help with any of what we were talking about at all? Um, Okay, so we need a point like where we start and where we end parsing as such of the packet, right? And every packet kind of starts with this packet header and all this stuff, right? Um, so we pass in the bytes initially. Is the whole thing gonna be a packet, like at the outermost thing, or is it a sequence of packets? Is the whole thing gonna be a single packet at the outermost layer? Okay, it is always gonna be a single packet at the outermost layer. You feel confident and proud of yourself wearing them, of course. Yeah. Yeah, sure, man. That is that is that is what I thought, yeah. Confident and proud. But definitely. That is the impression that everybody gets, don't they? When they think of themselves wearing thongs. It's like, yes, that is the ideal. You may not like it, but this is what peak performance looks like. Okay. Man. Are we going about this wrong? Should we instead of doing this, should we write it like a parser? Maybe we should write it like a parser, like in the sense, keep a finite state automaton kind of thing. Uh, a bunch of stuff what we did isn't really a waste of time so far. It's okay, we can still use most of this. Uh, but should we rewrite this as a parser, like a finite state automaton, and just kind of keep an index to the string? And why are you laughing? Why are you laughing so much? What did I say that was that funny? I don't know, man. My humor circuits are all haywire today because of the cold. I'm just trying to focus on the problem. Okay. So should we write it like a parser? Because if I think about it like a parser, like if I think about it like a finite state automaton, what are the states that we have, right? So at every state we can kind of be parsing the packet version, or we can be parsing the packet type ID, or we can be parsing sort of the next okay, so the packet type ID will tell us what the next thing to do is, right? Maybe we can make an FSA for this. Wait, let me just pull out my uh there it is. What is a finite state automaton? It's basically um okay, it's a fancy word for states connected to other states which will transition based on certain rules. It is a foundation of essentially parsing any data. Time Lord will probably be solving this question super quick because it does seem like very much up his alley. This is the sort of thing that he does at work after all. But the basic idea is that when you have a finite state automaton, it's a set of states, it's a collection of states and a collection of transitions between them with hard set rules for all the possible transitions from one state to another, right? So, and that kind of tells you how you can move between the states, right? Um, so you can move between the states and you can just kind of keep linearly parsing stuff, things like that, right? So yeah, packet question. Yeah. The packet question. It's a good question. I just feel like they've okay. Look, I feel like they could have kept half the number of rules and gotten the same point across. Like I just feel like a lot of these are just stupid. And on top of all this, like it's like if it's four, it's a literal packet, and if it's not four, it's a non-literal packet. Um, I feel like that non-literal part, that operator part, right? There's gonna be different types of operators in part two, and then we're gonna have to do something else with that. Hopefully, it's not gonna be too difficult. But yeah, because that's the part that they've very clearly said just ignore the operator type right now somewhere over here. One or more packets, blah blah blah. Um, they've specifically mentioned. Where did I mention that? Yeah, here. Right now, the specific operations aren't important. Focus on parsing the hierarchy of subpackets. This is what they've said. So basically, what that means is they're going to introduce that in part two. Have you seen our open hiring challenge? No. Language engineering challenge. Time box 3 hours. Technologies, whichever language you're interviewing for. Tests, nice to have. Documentation, nice to have. That should never be a nice to have, but okay. Um, Documentation can be a nice to have. Test should never be a nice to have. Challenge number one, configuration file validator. Consider a made-up configuration format called anon. Anon is very similar to JSON with a few changes. Supports trailing commas. How do they know that you've done it in 3 hours? So if this is like an open challenge, how do they know you've done it in 3 hours? Trailing commas allows comments and supports multi-line strings. In addition to everything else that JSON already supports. Write a validator for anon. Here are some of the rules that the validator can check for. Open brackets must be closed. Open strings must be closed. Escape sequences must be valid. Triple quotes cannot be used in keys. For example, this, and valid, blah, blah, blah is valid. Okay. Add as many rules as you can think of. For simplicity, assume that single quotes will not be used anywhere except inside strings. What does a non stand for? It's any other notation. Non's not an object. Okay, fine. Yeah, okay, cool. This looks like it would take more time. Yeah, it's a serious question. I think like, or more time. What do you mean by more time? More time than 3 hours? I feel like it should be doable within three. Uh, but it is going to be, yeah, it is still fundamentally the same as like the question that we're trying to solve here. The sort of the parsing thing is going to be kind of similar. There'll be some caveats here and there, but yeah. I suppose like what do you guys use for like language validators and stuff? Do you write in like Yak or something, by the way? Um, like the language for Yak, what's it called? Lex, I think. I forgot. It's been a while since I did all that in computer science. I've written a JSON parser before, so I could probably do this in under an hour. Yeah, if you've written a JSON parser, it's gonna take you very less time. Have you written a language before? Time Lord. Yeah. I find it interesting that you didn't ask me. Uh, but yeah, I mean, you would be right in assuming that I haven't written a language before. Mm, No, we don't. Who are you talking to? Technically, no. Okay. All right. So brought out the trusty old. Uh, oh yeah, I have to switch on. Okay. So can I keep this pin to start here? So there it is. Beautiful. mapping, windowsing function. There we go. Awesome. So now, yeah, fantastic. That works. Um, I've written Python plus plus, which is transpiled to Python language. We don't use Yak. Okay, I see. Okay. So, okay. Anyway, so the way we want to go is right. So essentially, initially we start. Okay. So the initial state which we will be in is that we will have to start parsing the version ID. So here we kind of pass 3 characters all the time, right? So it's like we're passing the version ID. We parse the version ID. Once we parse the version ID, we kind of go into always parsing the type ID. We always go into parsing the type ID, right? 100% of the time, right? So that's like your step two. Um, and then you kind of go into if the type ID is 4, if it's not equal to 4, not 4, right? So you have two rules there. So if it's 4 or not 4, right? So essentially, if it's 4, you are actually now parsing a literal, right? So I think it's basically just going to be groups, right? So you're going to parse the groups and okay, so in this case, this is actually okay. So I'm gonna call this a sort of a literal cloud, right? So this cloud is basically gonna be literal parsing. We parse a literal, which has no sub packets in a certain sense, right? We know that it has no sub packets. So it's gonna be a mm, yeah. So the first thing, so it's basically gonna be a group parser, right? So this is our literal cloud. Let me just write literal that way. Yeah, okay. And so the group can be, so when we parse the group, it's either going to be having a 1 or a 0, right? So if it's a 1, we go back to parsing another group. So it starts with 1, okay? We go back to parsing another group. And if it started with 0, then we are done. We terminate, right? We're done with with that particular packet as such. And in an operator case, it gets a little more complicated. Blah blah blah. Doing a weird thing here. In an operator case, okay, what we want to do is, yeah, I should have written it here. Operator, right? So if it's not 4, then it's an operator packet. And if it's an operator packet, then um, I kind of want to do it's a bit followed by a payload. So this initial bit is basically sort of you can consider it the type of the operator or the type of length type, the length type, right? Is it the length of the packets or the number of packets, right? So it's the, or I'll call it the count type, right? So are we counting the length, which is a single bit? It's a single bit, right? And if it's a 1, if it's a 1, okay, so this goes here, right? It goes here. If it's a 1, then in that case it's a number of packets, and if it's a 0, it's okay. So if it's a 0, it's a, now we have to treat it as two separate things. So here it's a how many how many do we need? We need, so it's now length type, so we need to read 15 bits and figure out the length in bits of the sub packets, right? So length, right, which is 15 bits, and otherwise this is going to be the number of packets, which is 11 bits sub packets, right? So we figure out both of these things, And now based on how many of it is, right, we have to call the overall thing again. We have to sort of recurse in a certain sense, right? And it goes back to version ID. So we kind of have to call the parse packet thing again, giving the start of where we are right now, right, as the beginning. Yeah, giving the start of where we are at the beginning, we kind of have to call the whole thing again, right? So it kind of recurses in, and when it comes out, end end state will kind of tell us where to resume from, right? In a certain sense, it'll tell us where to resume from. So because we need that, because we don't know the length and the number of each individual sub packet, we kind of need to figure that out from the rest of the parsing. So yeah, does that make sense? So end has to return and this is the only place where it really ends. It also kind of ends here after we are done with each of these. So after we have this kind of loops, right, with recursion, loop recurse, and then this kind of this doesn't loop recurse, I think. It just we do a single call, but we know that it's these many. I don't know if this will help us actually, because we need the packet to terminate. We need a termination to happen before when by the time we can get back, right? So this is really just gonna be something and it's gonna end, both of these end always has to return which packet we stopped at, because like if it's a literal packet that we process, we need to know where to continue the parsing from for the next call. Right, okay. Yeah, this is not gonna be easy. All right. It's not bit manipulation, but it is a lot of weird shit. Okay. Um, it's like, yeah, what I find annoying about this question is it's just less, it's not, it's, I don't know, it's not in, it's not something that is simple to implement in the sense that it has so many moving pieces, right? And I feel like if we fuck up, it's gonna be more because of some rather than some idea that we got wrong, it's going to be because of some implementation aspect, like a off by one error somewhere that we got wrong, right? And we have to be super careful about that's the part that's going to be a little bit annoying. Okay. So what I want to do is I want to get rid of all of these tests, unfortunately. um I don't think any of this helps us right now. We're gonna have to restructure a lot of this stuff. We will still do it TDD style, but we will try to think about this concept differently, right? So for now, let me just run this test, make sure it's failing for the right reasons. Let's optimize the imports. Let's run this test. Mm, make sure it's failing for the right reason, which is that an operation is not implemented. Fantastic. Now, let us start with the first test, right? Okay, so we have to write a parser for this, and we have to parse it starting at 0, and the parser will always start with the state at version ID, right? So we have to define our states, we will define our states, we'll define the transitions between the states, etc. We'll do all of that stuff. Okay, so mm, choose test name. So given packet, um, mm, okay, so let's initialize a parser, right? So val parser equals day16 dot parser, giving a byte ID, which basically we'll start with the literal one just so that our concept becomes a little bit simpler. We'll start with this guy right here, right? And the version number in this case is 6, right? So in this case, we do need this. Let's create that class. Let's put it in day16. Bytes or bytes, yeah, whatever, byte, bytes, right? So it's a string, cool. That's a parser. Val bytes, cool. Private val bytes, that's cooler. All right, cool. Um, so this is going to be our parser as a whole. It's not really going to be the state map. We'll create the state map inside the parser, right? Um, and what we want to do is assert equals 6 is parser dot get uh, parser dot parse. So what's going to be the output of the parser, right? It's actually going to be, it should give us the entire packet hierarchy, as it were, right? It should give us the entire packet hierarchy. I think that would be nice to have. That would be nice to have. Like if it gave us the whole packet hierarchy, that would be super nice to have. Okay. So at every transition, it really needs to figure out it needs to build up some sort of mutable state as it goes along, right? At every transition, like for example, once we read the version ID and the type ID, we should keep those, we should store those as such, but we have to pass it along, not to the state transitions themselves, but the parser as such should keep this as its state within that specific sub packet, as it were, right? We should build up the version ID, the type ID. Once we have that information, we can um, essentially construct a we can construct something which will give us literal. Okay, yeah, that sounds. hmm, how do you want to do this, right? So parser private val bytes string parser dot parse given 0. We have to start from 0, right? And in fact, like we can just leave that as default. Um, so that should give us the top level packet, right? So how we want to do that is create this as a member function, parse, it returns a packet. No, not a datagram packet, right? So let's create this class and we will put this inside day16 class packet. Okay, and the packet will contain a version ID, right? Mm, latent var, nah, yeah, I should just keep that in the constructor, right? I should keep that in the constructor. No? What do you mean? Val version ID integer, right? Oh, you're talking about. Oh, okay, I see. Python better. Braces. Regular expressions? Oh my fucking god, what is this? This- How, so do you actually, what you do is like you look at the braces and you fix the indentation. You fix the indentation for all the lines. Like you just delete the indentation for every line and then fix it by the brace levels. Is that right? True, false, and null keywords, plus plus operator. Plus plus would be nice to have. I've written a bro fuck compiler. It's brainfuck, but all the code is just the word bro. Wait, what? Isn't brainfuck like 8 separate words? Like eight separate symbols. There are 8 symbols, right, in brainfuck? I thought like that wouldn't work. Like how if all the code is the word bro, then how does that work? Are there 8 separate bros? Uh, fun parts. Okay, so I mean, I'll just leave this to do for now. Version ID. So what I want to do is pass dot version ID, right? There we go. And so that should be 6. And of course, like when we run this right now, it's gonna fail. Um, right, and that's quite nice. But we jump into this, right? And the way we're gonna start off, right? Oh, there are eight bros. Okay, there are eight bros. That's nice. Okay, bro, bro, bro. Quite nice. Seal class state. Can I make it private? Private seal class state. Okay. And the state has to have sort of a next thing. So fun next, which gives you a state, right? Abstract. Okay. And now let's make private class what's it gonna be called? So your initial state is version ID, which extends state, right? And of course, oh, state, there we go. And of course, it's going to be implement the members of next. So next is basically going to be, so sealed class has no state and no overridden equals. Okay. Um, so each of these states will return something, right? Like we have to parse something actually out of them. So when we are in version ID, Uh, it's not going to tell us anything actually. Uh, but based on the transition, we have to know, right? Based on the type ID and based on other stuff, we have to know. The state has to be aware of how you go into the next one. It's been a long time since I've written like a state transition thing, so I don't exactly remember how it's done. Like what the right sort of formulation is for this. Dot bro. I'm just surprised there's nothing bro code. That's quite nice. That's quite nice. Prints out hello bro. Incredible. Brain fuck to bro fuck. Is there a brain for like how do you actually bro fuck to brain for bro and bros output reverse mapping? Yeah, so this is the mapping. How does it actually run though? So this will compile it to brain fuck, but what the hell is T? Test codes that don't deserve their own repository. Okay, I see. How do you okay, so this is quite cool, but how do you actually execute the brain fuck? Do you have to use a separate thing for that, or do you have so yeah? I mean, this doesn't print out hello bro. Basically, it prints out the bro fuck equivalent for hello bro. Would that be right? I don't think it actually processes the brain fuck. We should have a Python brain fuck library. That should be there, like 100%, right? Python definitely has a brain fuck compiler. No state and no overridden equals. Oh, it has no state, right? We need a state for it, of course. So the version ID. Ah, okay. So okay, right. So how it's gonna be is every state is gonna be given a sort of a thing. Okay, so next should actually tell, yeah, so this should have an index, right? We should have an index from where to start the parsing, right? So, s- so start index, integer, and we should have a start index and we should have nothing else. Okay, so every state has to have a start index where we actually start the parsing of that state, right? So val no, so start index integer, right? And next, when we call, it has to have mm, so on the outside, we'll basically be calling state dot next on the outside, right? Um, but we don't know where pass that, but the state itself should be having that present. So the state should be aware. The state like should be aware of like which index we are currently looking at in a certain sense, right? So maybe it should be a var actually, var index int, right? Um, and now version ID is going to have the var index int override modifier. No, so is state index. And what's your problem? Okay, yeah, okay, yeah, that's fine. Um, so that gives us next when we call, we will basically return the next state, right? So that will basically return. For now, that can be to do. I think we are fine with the to do. We should be okay with that for now. Okay. We can probably just leave that in there for the time being, right? And we can, because we're never going to call next, right? So far, we'll add that behavior in, right? But we basically need a parse, which should be there for every state, right? Where we kind of want to parse the current state, and then that will update the index internally. So probably there has to be an abstract fun process. So we need to process the state, right? And this might return a value, which will be, in our case, an integer. It'll always return an integer, right? Uh, might return a null as well, or should it always return an integer? I think it should return an integer. Okay, let's implement those members process, right? So how do we want to go about that, right? So processing the version ID is pretty simple, right? We start at, yeah, the parser has val bytes, right? So can we access bytes from here? Bytes. No, we can't access bytes. Of course we can't. Um, we need an index. We also need to pass in bytes everywhere. So that's going to be the full string as such, right? That's going to be the full string. So val bytes string var index int. Hmm. Do we have to add that everywhere? Bytes comma index. Like that's going to be true for all the things, right? So I just want to know if like we can't have that. Mhm. Every state will need to have that. Okay, cool. All right. So how do you want to process this? So we basically have, mm, we take bytes dot substring starting from index to or until index plus 3, right? We know it's always three bytes, right? So we take that and um, dot to integer radix 2, right? And we take that and put this as the version ID, right? And we update index plus equal to 3 and return version ID. Cool. Yeah. So we do that. And when we call next, yeah, we'll come to that, right? So for now, the packet that it's going to return will basically just be return version ID of bytes, comma. Okay, so this needs to have a start index, which is 0, right? Or which is an integer equal to 0. And this one will have bytes comma start index dot. Okay, so this returns dot process. Um, and we kind of need to just take this and put into a packet, right? Return packet of that, right? Cool. So now we should be able to see that succeeding. But of course, like we'll have like further failures later on. That's fine, right? We'll induce those as we go along, right? So given a packet, okay. So let's modify this test, right? Version ID and type ID, right? So in this case, our type ID is 4, right? Assert equals 4, which is parser dot parse dot. Okay, so in that case, parser dot parse, we will control alt v this. We'll call this packet. Okay, packet dot version ID, packet dot type ID, right? And let's create that as a member property. Val type ID int. Can we move this into the constructor parameters? There we go. Public refactor. Cool. So that's fine. I feel like class could be a like packet could be a data class, but it's fine. We don't need that right now, so we leave that the way it is. Abstract fun next, which is state. Yeah, we'll come to that. It doesn't have to be a data class because we aren't comparing packets anytime, I think. I don't think it matters. So now what we need to do is we actually need to, so it's not enough because this test is going to fail, right? If we run this, of course, the first test will fail, but the second test will also fail, right? It's expected 4, but it was 0, because it just defaults to 0. So that's not what we want. Let's implement that, right? So in this case, what we have to do is we have to implement next, right? So if we go into next, so okay, so the first thing we need to do is we have to run and verify that we will get, yeah, so cool. So initially we start at 0, right? When we start the parser, we kind of start at 0. Ref var state, yeah, so var state equals version ID, because we haven't started parsing it yet, right? Giving the start, giving the bytes and the start index. Cool. All right. And now what we want to do is, what the fuck am I doing? Right. Now what we want to do is, while, mm, so we want to build, oh, so I might want to write a builder maybe. I don't know if I want to write a builder. Do I want to write a builder? A builder pattern? Builder pattern feels like it would be nice to have, right? In this particular case. Yeah, and build packet as I go along. Mm, yeah, I feel like a builder pattern might be nice to have. Um, like I'm just thinking, right? Because I want to leave these as vals. I think it's nice to have them as vals instead of vars. Or sort of like latent vars, right? Which I know like can be fine, but yeah, instead of that, like I feel like this is a better way to keep, to think about this. But while, huh, how do we know that we're not done? We kind of have to keep going into the next, etc. I think eventually we will get a state where we don't have any more states to go through, right? So while question mark, right? So yeah, so while state is not equal to null, right? What's your problem? State. Okay, so let's make the state question mark. Okay, there we go. So we start with that as a version ID state, right? And while state is not equal to null, what we're going to do is we're going to call state equals state dot next, right? Which eventually will be null, which is fine. But now what we want to do is we want to call, oh yeah, so next will be state question mark. Version ID will return a state, and not a state question mark, which will be which is fine for us. But yeah, we'll kind of, as we add states, we'll keep the sort of the termination state as we go along, return null, right? So now mm, when state, so while state is not equal to null, so I think state is smart casted as state, right? So when state is version ID, uh, then in that case to do, right? Um, and other cases will be also handled, right? So what we need to do is we kind of need to build up. Yeah, so we probably need a builder for this guy. So class builder. Can we have it in a companion object instead? Like instead of keeping the thing, we can probably have it as a companion object, right? Like you're thinking companion object, but there's only one instance of the companion object. The builder, the whole point of the builder is like we'll need to create an instance of it. Wait, so Kotlin, is there a smart way to do a Kotlin builder pattern? Um, Relational Kotlin bread init builder. Okay, so it's practically the same. There's no big difference. It's just everything is a var, obviously. Everything just kind of starts off as null, and finally, when we call build, it'll build a food order of this where, okay, so these are nullable. So the whole point of like using a builder pattern is that we know full advantage of Kotlin, data class builder, idiomatic, named and default parameters that help to minimize the number of overloads. Yeah, I suppose that helps. Conclusion, builder pattern solves, blah, blah, blah. Okay. Utilizing named and default parameters. Mm, don't use builder in Kotlin. What? Mm, the fuck? No, this doesn't solve the problem of using a builder at all. The, the thing that a builder pattern solves is that you can actually you can you can you can accumulate data over time in the builder, and eventually you can just, yeah, you can accumulate data over time, and eventually you can just use the builder to, put the data. Like, yeah, that's like the advantage you get out of it. Okay, whatever. I'm just gonna go ahead do this, right? So, latent var. So this will have latent vars, huh? Because hmm, yeah, it'll technically have latent vars on some specific things, but when we call sort of dot build or whatever to access it, it will be all initialized is what we are assuming, right? So the packet can have a value. Uh, so in our case, we don't need the length of the packet to actually be as a part of it, right? Like that doesn't matter. The length bits for the operator packets don't matter. We just want the packet in the sub packets, right? Okay. So it may or may not have sub packets. So the sub packets should really be sort of a list. Yeah, okay. So we'll come to that. We'll add those in as it goes, but latent var version ID is an integer. What's your problem? on properties of primitive types. What? Convert a not null delegate by delegates dot not null. Is that wait, what? You can't put late in it on initializing a not null property outside. Declared as having a non-null type must be initialized. Late in it probably late in it has unfortunate. So apparently we can't do it for primitives. Okay. Uh, what is this not null delegate? Delegates dot not null int returns a property delegate for a read write property with a not null value that is initialized during object construction time at a later time. Trying to read the property before the initialize results in an exception. I see. But what's the type of version ID now? It's still an integer. T any what does this return? It returns a not null var. I don't even know what that is. Value get value returns T read write property question. Very interesting. I could read this property delegate stuff. Like, I don't really know how that works, so I should read that. Hmm, I should read that. I don't really know how that works. Okay. So, okay, so if we go back here, hmm, delegates of T, let's just close that. All right. So this is the version ID var type ID or later var. I'll just type that so we're able to integer, right? So we are able to convert a not null delegate. I think that's fine. And now, uh, how we want to do this is if we just leave this as the builder, I think finally we can just call build. So fun build, um, which will be uh, equal to packet of version ID, type ID, right? So can we convert that into an expression body? Because I would rather convert to a block body. Yeah, there we go. Right. So for now it's fine, but like yeah, that will become like a little bit of a problem for us later on. So I think like I'll leave it this way. So what we're gonna do is we are gonna return version ID, type ID. So we'll just keep a builder and we'll set these things as we go along, right? And we'll call dot build at the very end. Cool. So how we want to do this is version ID. Okay, so we want to keep a packet builder, right? So var val packet builder equals packet dot builder, right? So we are creating a packet builder initially. So if it's version ID, then we say that packet builder dot version ID is equal to state dot uh, process, which actually gives us yeah. So now in this case, state is of type state question mark. Interesting. It does it not automatically wait? So Kotlin sealed class. I think we have a thing about how to use when expressions on them, right? When expression, there we go. We cover all the use cases. Why does the smart cast not work? I don't think it matters to be honest, because we do have process on the top level. Um, and then we finally call state next, right? So now at this point, we will have it like we will have it fail because it'll basically return the version ID, right? State dot next, we have to do this while state not equal to null, we have to do that. And so yeah, we can do a thing here. We can return packet builder dot build. There we go, right? So we can do that, and if we run this, we will have that fail, of course, but it'll fail for a very interesting reason, right? So of course, like this is not yet implemented, but this is also going to a not yet implemented over here. So maybe we can just return null, right? For now, let's just change that to state question mark, so that solves that error. But if we see this, we will have a packet builder exception in this case. Um, type ID should be initialized, right? In this case, what I'm going to do is I should have probably removed type ID from here. Like I shouldn't have kept type ID yet. The problem is we do need it to be initialized so that this can run. Um, is equal to do. So, oh, but maybe that will prevent us from initializing as a whole. Yeah. Okay, it's fine. It's fine. I'll leave it this way. Okay. So now we have to actually implement that part, right? So what we need to do for that is not return null from here, but we actually need to return um, the next sort of thing, right? So we'll implement that first. Private class type ID, giving again bytes, string, index, int, extend state with bytes and index. Oh, actually, state bytes comma index. There we go. Um, what's your problem now? Implement the members. Let's do that. Let's, yeah, keep it that way. We need to return type ID, giving in bytes, of course, and the index, right? There we go. And this can be made non-nullable now. Mm, Now when we run this, we'll actually get the error at a different spot, right? We get a not implemented over here in next, not in process. That's weird. I thought we'd get that. Oh yeah, yeah, but that's because we don't have that as a state, right? So non-exhaustive, let's add the remaining branches. So yeah, now we should actually get that as a remaining branch as is type ID to do, right? So there we go. We should be able to get that, right? So mm, let's add braces. Actually, we shouldn't be. We don't need to move. We don't need to put braces there or here actually. So packet builder dot type ID equals state dot process, right? So that gives us the type ID. Cool. Now, next here will be different. So for now, we can actually just do it as null, right? Return null. Uh, cool. And process, we can implement it as, actually, let's just move this down here. So it stays a little bit. Otherwise, I have to reorg every single one. So for some reason, it seems to put next and then process. Maybe it's like MNOP. Yeah, it's probably alphabetical order reason. Oh, no, it's because next and process are in this order over here. No wonder. Yeah, let's just move that up. Let's just move that up. I think it should implement in the same order now. Okay, so to process this, we probably, yeah, so we will start from, again, it's 3 bytes, right? So val type ID, um, I can just do the exact same processing. Let's copy that and let's paste that in there, except let's shift F6U to make it, let's shift F6 to make it type ID, right? So we do that index plus equal to 3, and we should have that passing now, right? We should have that passing now. There we go. Fantastico, right? So type ID, everything is fine. So it is reading these three, then it's reading those three. And after that, we kind of have to continue, right? So now what we want to do is given a literal packet, all right? So that's the next step. Given a literal packet, um, we read the value as properties something. Given a literal packet, what are we supposed to do? Yes. Yeah. What was the value of that packet? This was the one we copied, right? Yeah. So 2021. Okay. So val parser equals day 16. So this is going to be exactly the same stuff. Um, right, and we don't need to do the packet.version ID or type ID. We actually need to check the yeah, we actually need to check the value, right? Um, so value, and let's just create that as a member property, val value int, and let's move it to the constructor parameters, value, altar, okay. Mm, yeah, there is a problem with this, which is that it needn't actually be, yeah, so it's nullable, right? And here we are saying that it's 6. We should keep it as nullable because the value can be null since it needn't actually have a value, which is fine, right? Um, cool. So now when we do this, if we 6 and if we run this test, it will fail, of course, right? It'll say that the 6 but was 0. And that's fine, I think. I don't know why it's 0 by default. I thought it would have been null by default. But it's not, right? So yeah, that's fine, I think. Um, what we need to do is um, so now in this case, var value equals int question mark, or is an int question mark. What's your problem? Add an initializer equals null, right? And we are just gonna create the value. So value, right? We're gonna pass that in. And of course, if we run the test again, we should say that it's null actually. Expected 6 bit was null, right? Because that was the default value that was passed in, right? So now what we need to do is we go back here and we actually build ourselves in type ID next. We'll return that instead of that. We'll fit whatever we're parsing for literals, right? So the literal cloud. So literals are actually going to be processed as group, right? So I'll call that literal group as such, right? Um, so we are gonna do another. Can I extend the class by going here and creating go to subclasses, do subclass of state zero matches? What the fuck? Control B. Yeah, there we go. Okay, so we do have that, but for some reason it only shows up in the shortcut. Okay, so private class. Mm, from type ID, I'm actually gonna call this literal group, right? So we're going to parse in a literal group each time, and the value that it's going to return, we're going to take that and oh, so we have to actually combine those bits, right? We have to combine those bits when we take it. Next will initialize with whatever we have already read so far. Hmm. Will initialize with whatever we have already read so far, and it will go into, yeah. So, all right. So type ID equals that. Big byte string. Wait, okay. Can we set this type ID as a latent var, right? So here we can do latent var type ID, which is an integer, right? And convert it to non-null delegate and type ID, return type ID. All right. So we do that because when we call next, we need to know, and we would have called process once before we know that, right? So we need to know what the type ID is so that we can choose the type ID to actually go into either literal or operator, right? So I'll leave it the way it is right now. And literal group we will consider, right? So literal group we will consider. Um, so this one not yet implemented, okay, but we want to skip this test for now. Can I just add ignore you for the time being? Um, okay. So we'll just add ignore that test so that we can run all the tests apart from that one. Okay. Now, um, what do we want to do? So I want to take So, okay. So the implementation of literal group is going to be a little bit different, right? So we of course have bytes and index uh, as well, right? Because that tells us what to start like doing that. And will also have a val previous groups or previous um, which is a string, right? Which is a string, and that gives us state uh, bytes index. There we go, right? And we kind of want to take that. Let's implement the members, both of them, right? Okay. Now, what I want to do is I want to get into this to do not yet implemented, right? So from type ID, I'm just going to do an if type ID equals 4. Then in that case, the next state is going to be a return literal group passing in bytes um, and the index and previous accumulated, which in our case is just null, right? So since we don't really have any previously accumulated stuff at this point, I think this should just be equals that by default. So we don't have to add that parameter in here, right? So we don't have to add that parameter in there. And why are you question marking? Next always returns non-null type. It doesn't though. It's only if, right? Oh, yeah, 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 okay. Else, well, in our case, else return null, right? So return null. And we can probably lift the return out. So if type ID, then we'll return literal group. Else, we'll worry about the other part later, right? So now if we go and run this, right? Let's run all the tests actually, and the ignored one should get ignored by itself. Um, yeah, so that one's ignored. Can we hide the ignored test? There we go. Uh, they both fail because they go into literal group. This also goes into the literal group and says it's not yet implemented, right? So that's kind of the problem. They both fail at this state, right? Um, yeah, okay. So now we kind of want to add in the exhaustive, like add this is little group to do. And if we run this now, we will see that it fails over here, right? So it fails at both of them will fail at day, yeah, right over here. So if it's a little group, what do we do, right? We have to implement the process function. So let's implement that, right? Let's implement that. So we want we want the literal group to have if its first bit of that sort of group of 5 is 1, right? Then we return, and can we make it an int question mark at this stage? Okay, so that has to be okay. So because okay, we can only change it to like a derived thing. So it has to return an integer. Uh, the thing is, we might not, through processing a literal group, have an integer to deal with, right, by this time. So, but it's fine actually, because every literal group will have an integer, but the only thing is we need to take in, so the 5 bits which are labeled, yeah, so 0111 is basically going to be, what is this in, so Python, uh, or I can create a Kotlin scratch file. Let's create a Kotlin. We have a scratch file already, right? So, okay, so that's 6, right? Or no, it's not. It's 7, okay? So if we take this, right, and we uh power it up, like, or multiply it by 2 to the power 4 each time, right? So it's like this is gonna be 0111 and then 1110 and then 0101, right? So it's gonna be okay. Let me just use this. Or wait, I have this over here, right? So it's gonna be 0111, 1110, 0101. So 0101, right? So when we have this, this basically gets elevated by. So this is if we take it as 2 to the power 0. If we shifted it by 1, so in this case it's shifted by that's in times 2 to the power of 1, right? Times 2 to the power of 0 is 2, right? Okay. So if we don't shift it at all, but now in this case we've shifted it by 8 places, so it's times 2 to the power 8, I think, right? 2 to the power 8. I don't know how to do power. Uh, okay, maybe we have to implement a power to power 8. Do we have that as a thing? Okay, wait, Kotlin power, or we can just left shift by 8, right? Mm, Shift left by 8. If you do it this way, it's 1792 plus, um, so plus this stuff dot 2 int radix 2, uh, shift left by 4 plus this stuff dot 2 int 2 not shifted left at all. If you just add them up, what do we end up with? Do we end up with 2021? Come on, one bit. Okay. Maybe we should have done too long. Mm, dot too long. Oh, it still ends up with like a massive value. Or maybe that's because that plus because it shouldn't be that big numbers anyway. I think 2 int should be sufficient. Yeah, 2021. There we go. There we go. There we go. It was just the order of the operations I was fucking it up. All right, cool. So that is 2021. Mm-hmm. So shift left 8, shift left. Okay. So if we do it this way, so okay, so it's more like 2 to the power 3, 2 to the power 2, 2 to the power 1, right? Or more like shift left of 2 is shift left 3. Uh, that's the child 3. 2. No, 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 no. Sorry. That's 1 shift left 3, right? Sorry. Yeah, there we go. 1 shift left 3, 1 shift left 2, and 1 shift left 1. That gives us the number, right? So I think what we can do is essentially just take every single one, right? As we're getting it, and we can accumulate it. We can accumulate it in a thing, right? And once we have that thing, we can go ahead and update the overall. Uh, yeah, we can do that. We can do that, right? So once we update, we can go ahead and do the, yeah. So literal group at every step is just going to give us that particular thing. So we don't actually have to get previous accumulated. I think that's like a thing we don't have to do, but it's more like we stop when the state goes to null, right? We stop when the state goes to null. So yeah, so let's do that. Mm, State not equal to null is literal group. Okay. Do return to build. Yeah, okay. So it's index. Okay. So how we want to do this is we want to maintain the counter each time. Um, Yeah, and we want to shift left. Okay, so we just want to shift left it by 4 each time we find one, right? We want to shift left the data by 4 each time we find one, and we want to add the new data, right? So yeah, the new thing which we find. So while state not equal to null, packet builder dot packet dot builder. So this value starts off as null, and we want to accumulate within value, right? As a var, so it's fine, right? So okay, literal group to do. So if packet builder dot value is null, then in that case we start off with mm, is equal to 0. So we set it as 0 initially, right? And now packet builder dot value uh, is equal to packet builder dot value SHL 4. So we shift left it by 4. We double exclamation point that, right? Actually, we don't need to double exclamation point it if we mm, save it as a thing. We Control Alt V this, cannot perform refactoring without an expression. Control Alt V, replace all two occurrences. Value equals bracket builder dot value. If value double equals null, then value equals 0, right? Now we don't need to do value equals value shift left by 4, change to var. Oh, there we go. Yeah, it has to be a var. Of course, it has to be a var. Redundant assignment. Wait, what? Remove redundant assignment. Oh, no, no, no. Okay. Now value plus equal to state dot process. All right. So that processes the state. Cool. And once we have that, we should be good, right? And finally, the, the and we set packet builder dot value equals value. There we go. There we go. Right? Yeah. So we do this. Cool. And that gives us cool. So we left shift, we do that. Okay. And the way we want to implement process, and of course, if we run this right now, what we will see is in the case of literal groups, it'll jump into process and it'll say it's not yet implemented. So let's implement that. That's very, very simple, right? All we have to do is we have to take the bytes dot substring starting from index plus 1 uh, to or yeah. So it's basically we have to read like 4 bytes as such. Okay, so how we want to do that is process. Yeah, so process doesn't matter. It's actually the state that will matter for us, right? So re- okay, so bytes dot wait, can I access it with this 1.3? No, I can't, unfortunately. No, we can create an extension function for passing in the range, but I think we can just instead do a dot substring. That'll be fine, right? So dot substring range index. So we start with index plus 1, and we say till index plus 5. Wait, so it's like index is the zeroth bit, and we need to do 1, 2, 3 plus 1, 2, 3, 4. So index plus 4, right? We need to do this dot 2 inch with the radix 2, and we kind of have to store that as a value as the value. There we go. And what we do now is we do index plus equal to 5 because we are processing 5 of them. Uh, we do need, yeah, so process will need the type at the top. So terminating is terminating, right? So late init var is terminating Boolean, right? Technically, I can keep it as var is terminating equals true at the start, and I can change that, right? So is terminating equals bytes of index, uh, bytes of index equals uh, if bytes of index double equal to 1, then we do uh, false. Is true. The problem mismatch. Infer type is unit, but Boolean was expected. What? Is terminating equals if bytes of index. What am I doing wrong? X. No, it is false, right? Uh, yeah. So that's what that does, and it increments the index, return value, right, at the end. So we do that, and that's how we process that one. And then for next, we basically want to do if is terminating, then we return null, more like uh, up, else return another literal group given bytes and index, right? There we go. So is the return out of if. Cool, there we go. I think that should solve our problem as such, right? And we should be able to get everything working now. And if we run the tests, we should be able to see has failed. What? Expected 6. Wait. Hang on. What? That doesn't make any sense. We read the value as 2021. Oh, did I hit 6? Oh, fuck me. 2021. Yeah, there we go. I think I copy pasted the previous test. Okay, that was the problem. Cool. So let's run this again and we should see that pass. Beautiful. All right. Cool. Slow but steady progress. Slow progress but steady progress. Better than no progress at all. All right. Let's go. Also, I just realized the music has been off the entire time. There we go. I just completely forgot about that. Let me reduce the volume a little bit because I think that'll be a little bit too loud because I am trying to speak super low. I'm trying to speak just about as much volume as necessary. Anyway, um, do we have anyone by there? Oh, we have someone's just lurking in the chat. Okay. Let's go back to right. So what do we want? Right. Okay. So at this point, we want to verify. So we are done with processing literals. We want to process operators next, right? We want to process operators next. I think we have a very nice structure so far, but let's see if that breaks down when it comes to operator, right? When it comes to operators. So okay, so given an operator packet, we okay. So the first thing we want to make sure is that we are entering the sub packet as it were, right? Yeah. can I construct something which has only one sub packet in it? It'll be nice to have like an example of like one packet with a single sub packet, right? I just want to construct an example. Can I have one or more sub packets? No? Right. So, okay, maybe the first thing we want to do is the total length in bits part. We kind of want to verify this particular type, right? So the bit labeled 0 is the length type ID. Length is a 15-bit number, okay? And that contains the length of the subpackets in bits. 11 bits labeled A contain the first subpacket, a literal value representing the number 10. B contains the second subpacket, a literal value representing the number 20. Okay. Mm, so the top level we know has a single packet only, right? Single packet at the outermost layer, which can contain other packets. Okay. Mm, anyway, give like a couple of minutes. I will be back. I'll need to refill some water, and I will be back super quick. Let me just quickly take a break. All right, okay, I'm back. Okay, wait, hang on. Let's see one thing, right, which I wanted to make sure was that at the start index, yeah, we kind of start with the version ID at the start index, right? So that part is fine. Now, when we are talking about sub packets, that's going to be a thing that will matter for us, right? So right now what happens is if we look at an operator string, so based on the type ID, it actually just goes and terminates itself, right? It kind of just goes and says, yeah, I'm done, right? So that's going to cause problems for us. We just need to verify that that won't cause problems for us. So yeah, um, what we need to verify over there would be that fun. Um, so let's put given an operator packet mm, uh, of so it's either going to be a length of packets or a number of packets, right? So of length type we um, can uh, okay, cool, whatever. Process it. I'm just saying like process it in the sense that we know which sort of packet type it is in a certain, yeah, so that's pretty much what we want to know, right? So okay, bit labeling the purpose. So this is a length type, okay, and we want to do that, right? So val parser equals day16 dot parser given the bytes that, right? Uh, val packet equals parser dot parse, right? And what we want to assert is that The length type is, yeah. Normally, ideally, what I would have done is I would have written a mock I would have written like a stub sort of thing for the state transitions as such and verified that we go into that state, right? I would have verified that we go into that state. But for now, all I'm going to verify is that we actually have um sort of a sub packet is not null, right? That in the sense that we are aware that there is a sub packet involved. Um, at least one sub packet, right? But we don't know how many those are. We're gonna have to recurse for that. Yeah, but we should be able to figure out at least that we have a sub packet involved, right? So yeah, we can recurse for that actually. We can do that part. I think that should be fairly straightforward for us. What's the advantage of knowing the length of the sub packets, by the way? I don't know. It doesn't tell you where it needs to terminate, right? Like if you have an operator packet, maybe it does, maybe it does, maybe it tells you where you need to terminate in a sense. I don't know. There is one problem though. That process always returns an integer. I think that's a little bit of an issue for us. That process always returns an integer. And when do we call process? Do we call it only on the individual types? Process, yeah, we call it only on the individual types, right? So I think our problem is basically going to be that when we are talking about this, yeah, our problem is basically going to be that we will know length, but after that, and the process of that can return the length, that's fine. But after that, we need to know the length of the sub packets, but it could be more than one sub packet, right? So we parse with the entire thing. Mm, that won't help us, will it? Because at some point we will end, and when we end, we kind of need to know the index that we were at last time. So when we get null, we need to know what the index is. State.next, okay. So at this point, state would be null, and we no longer have a state, so we no longer have an index, which is a little bit of a problem for us, isn't it? Because once we reach the end, we need to know that we've actually. Hmm. But that will be in a recursive call. So I think we should be fine. One thing is that even an operator has to sort of terminate. The question is, will we know that we are terminating or not? And if it has to terminate, the last thing in any operator packet also has to be a literal, right? Because if it is another operator, if it's another operator, I'm just thinking like, is there any point in knowing what the length of the subpackets is? It's useful knowing the number of the subpackets, but is there any point in knowing the length? I suppose instead of returning null, we should probably return a terminal state, which just gives us the index by which we are able to tell the index, right? Where there is no next. We don't call next on a terminal state. So we always end at a terminal, right? And we are able to sort of process based on, hmm, like null works so far, but the problem is when we need the index that we've gotten to at the point when we reach a terminal state so that we can actually start processing the next packet from the beginning with version number and all that stuff. Mm, Or do we always, like I said, do we always return? We'll call parse, we'll get some packets, but getting the packets isn't enough, right? We need to know where to call parse from the next time. So we need to know where we terminated the previous sub packet. Is that right? There is another problem, by the way, which is basically the padding bits. So if we look at this, even the literal packet, this is an operator. Even if you look at the literal packet, we have this CCCC starting from 0, and it is having padding bits at the end. And we don't know how many bits to skip there. I suppose that's what knowing the number of bits will help with. But I was just thinking, like, any remaining packets that don't, it'll still help, right? Like, we shouldn't have to have that as a concern for us. But hmm, yeah, this can get complicated really fast. The problem is, if this is a literal packet, we have to terminate at the end, knowing that we are done reading all the terminal, sort of the padding bits as well. Thing though is we don't know if these are padding bits at this point or whether it's due to another packet starting. This is the version bits for the next packet starting, right? Literal value, binary number is padded with leading zeros under its length. Mhm. Hexadecimal representation and should be ignored. Oh, they're due to the hexadecimal representation. Oh, fuck me. Okay. So every packet we know is gonna be some length of 4 bits. Like it's gonna be yeah. So that's always gonna be an issue for us, isn't it? Because if every packet is always gonna be a multiple of 4 bits, then we need to know how many to read up until. And if we get the terminal packet, we have to skip that many until the next multiple of 4 as such, right? Uh, because if it's a hexadecimal, yeah, every hexadecimal, few extra, not part of the transmission, should be ignored. Okay. Extra 0 bits might be there, and we kind of had to skip that at the terminal state, right? And parsing a packet should always return a, yeah, parsing should always return a packet, but it should also return the state. It should also return the point at which this packet ends in the string, I feel, right? So the packet should contain sort of the terminal index, as it were, where to begin parsing next. So post parse index, right? It should contain that as well. Ends at, right? Like an ends at index, which is exclusive. How do I want to implement this? Kind of sucks that we're on day 16. This is fairly complicated. Version ID, type ID, value. Um, so I think there should be an ends at. All right, can we put parameters on separate lines? There we go. So what terminal is going to do is to process. Next is obviously not going to return anything, but terminal will tell you what that end byte is. It'll tell you what that end byte is. All right. So how we're going to do that is, so if the index happens to be currently the byte that we are on happens to be a perfect multiple of 4, as it were. All right. If it happens to be a perfect multiple of 4, so it's sort of like 0, 1, 2, 3, 4, 5, 6, 7, and so on, right? So 0, 1, 2, 3, 4, 5, 6, 7, etc. So if it were a perfect multiple of 4, it would actually mod 4 to become 0. But if it were any other case, so let's say it were over here, so 0, 1, 2, 3, right? So 3 mod 4 would be 3, right? And so we'd have to do 4. The difference to reach 4 would be 1. So we need to return 1. We need to return index plus 1 as such, right? Index plus 1 as the thing. So it's more like index plus equal to uh, index mod 4. Okay, so wait. So first index mod 4. This gives us the remainder. All right. And now 4 minus index mod 4 will tell us what we need to do with, yeah. So, but this itself could be, has to be modded 4. And the reason for that is because index plus equal to that thing. Why? Because um okay, the reason for that is because if it ends, so it's okay, so the conditions are okay. So if I do this, let's copy that, let's put that in the scratch file, right? And you will see the problem point, right? So uh, for index in 0 to 100, uh, we basically do a print uh, ln of that, where mod has to be defined because we don't have common utils over here. So let's just put that over here. So you'll actually see what we will need, what will be the next end bit as such. So index plus that. All right. So basically, whoop, something is just wrong. Index in 0 to 100, 4 minus index mod 4, mod 4. What? Index plus. Oh, right. Sorry. That has to be like that again. So you'll see that. So for 0, it's 0. For 1, it'll become 4. For 2, it'll become 4. Actually, let's do a println of um, two things. So let's put dollar index maps to that, right? There we go. So 0 is 0, but once it reaches index 1, that means it has to jump to 4. Once it reaches like 2, 3, 4, all of them are 4. That's the next index, right? As it were. 5 would be 8, 6 would be 8, 7 would be 8, 8 would be 8, but 9 would be 12, right? And so on. So I think this algorithm makes sense, right? It gives you the terminal, the point where to stop, right? How many to pad with. So how much the padding is, right? So it skips the padding. this skips the padding as such, right? So process will skip the padding. There is no next. And what we're going to do is we are going to check while state not equal to null. This is obviously a useless check. Uh, we have to do it this way. There is no nullable anymore, right? So while state is not terminal, we do this, right? So is terminal never has to be checked. Um, I feel like, but it has to be checked. Why? This terminal will never happen because it's is not terminal is verified here. Is not terminal verified here. So I think this should be an not implement error. Yeah, throw. Right. We should never hit that state. But at the end of its state is going to be terminal state. Okay. And we return packet builder dot build. What we have to do is actually put packet builder dot ends at equals state dot process. There we go. And that gives us our final. So the final state, the terminal state is also processed. And at that point, we are through, right? We never call next on it because we make sure that it's not the terminal state. We never call next on it. Cool. And that kind of gives us, so we have to verify that in this case, our terminal termination is actually at, what is that? How many, how many values is this, right? So this is equal to a bytes dot size, right? So it should be equal to this bytes dot size. So control alt V, this thing, bytes is that, parser, cool, and assert equals um, bytes dot size dot length, yeah, is packet dot ends at. There we go. Let's run the tests again. Yeah, that succeeds. Cool. We have an ignore test. That's not a problem, right? But it succeeds. Okay. Now we kind of need to figure out the length parsing thing, operator packet. Yeah, so this is still on to do, right? Okay. So I feel like that helps us massively because that tells us that we are skipping past whatever, and yeah, we can change the terminal state to, you know, work the way we want it to, depending on like how we want to solve it. Um, yeah. So now for length type, right? How do we solve this? So this is supposed to have 3 bits as such, right? Okay. Dot parse to do something, something, something. Okay. Now, how we want to solve that is if we have literal group, terminal, okay, and terminal can go down. Uh, yeah, can go down here, right? And fine. So this is a padding skip which we've done, right? So skip, yeah. So this is like a padding skip, right? Mm, cool. Actually, can't we just do a 4 minus index mod 4? Uh, do we even need to do it this way? We run this. Oh, yeah, that works, right? That just works. Okay. So it's just 4 minus index. We don't have to do that stuff. So if I went here, how does that look? 4 minus index mod 4. Okay. Wait. Index plus 4 minus index mod 4. So it's just 4 minus index. There we go. Right. And if we run the tests, it should be fine. So this goes into to do for, yeah, the rest of that test. Okay, cool. Process it. So how do we process? How do we perform this? Okay. So now, okay, so if we go back to sort of the type ID part, right? If we go back to the type ID part, we can see that if type ID is 4, it's fine, otherwise it returns terminal. This is not supposed to be what happens, right? So else to do, this is supposed to be a to do here, right? And yeah, what do we want to assert at the end of this, right? We probably want to assert, okay, so given the option that we have here, we have some sub packets, right? Let's just assert that it contains 3 packets, right? And we'll solve the entire thing. Let's see what happens, right? So given the bit labeled L contains the length of the sub packets. Okay. So we have how many sub packets was that? 2 sub packets, A and B, right? So to do uh, so we take this packet dot parse, okay, and now assert equals packet dot packets dot length um, to is packets dot sub packets dot length or dot size, I think. Yeah, size will be the correct thing. So create the member property that as a construction parameter, um, sub packets, which is of data type, um, list of packet. Yeah, and its default value. Let's just refactor that. So sub packets, if we go sub packets val sub packets, let's just rename save sub packets to the dictionary, right? So list packet, that's fine. And now it's gonna have a compilation error. Why? Ah, yeah, here. So here we need to pass, let's just pass in to do for now. What's your problem? Unreachable code. Oh, unfortunately, let's pass in, oh, list. Okay, so it can be null. It can be null. Let's pass in a null for now in that case. Right? So the subpackets is null. Let's just add names to the call arguments, and let's sort of put each on its own line. I don't know why it's not giving me arguments on separate lines. There we go. Fantastic. Okay, I love you, IntelliJ. You're so good. Okay, so subpackets question mark size. We know it's gonna be non-null, but if we run this right now, it's obviously gonna say expected to was null, or it's gonna go into operation not implemented because yeah, type ID, it's an else case, right? So that's as expected. So let's actually create now literal group is present. Now at this point, we actually need operator, which is going to be what we are trying to process because we have processed the type ID. We have to go into operator now, right? So, and then we kind of start with the sub packets, right? So operator packet, uh, else operator, given mm, literal group had nothing else. So this has a bytes string. Okay, so let's create so okay, we'll keep the to do for now. We'll create the operator thing now here, right? So private class operator which has bytes string and index in, and it also has a type ID which is an integer. It extends state with the bytes index, and we will implement the members. Obviously, we'll just leave those as to do for now, and we'll just do operator of bytes index the type ID, where we will pass in the type ID as well. Cool, because I'm pretty sure we'll need that for part 2, right? So in our case, this is just going to be val type ID. Cool. What's your problem? Type ID is never used. I'm okay with that. Perfectly fine. Perfectly all right. Um, we'll work on that for part 2, right? So process and next. Now, of course, if we run this again, we will have the to do, which will fail somewhere else. Instantiating tests, operation is not yet implemented, which goes into, well, it goes into next actually, because we don't actually have a thing um, in the when expression. So let's add the remaining branches is operator to do. Now at this point it will fail because it will say, that thing over there. So what we need to do actually is to process the operator and say whether it is a length type or this one type, right? And based on that, we have to actually process it. Um, so it's like, yeah. So, well, is length type uh, or length type equals state dot process, right? So that gives us the length type. Um, or not length type, it gives us the sort of the count type, right? So should we count the length or should we count the yeah, so it should be 0, right? For that example, p packet o 0 is the length type ID, 15-bit number. Okay, so it should be 0 if the count type is 0. So it will be either 0 or 1. I don't like the fact that we're using sort of an integer for this, but it's okay. I'll I'll go ahead with that, right? I don't mind. I think that's fine. Actually, processing it should not return this, I don't think, right? Shouldn't return this. If it's an operator, we should process the operation as such, and we should return whatever is the value that comes out of it. I'm pretty sure that's going to be the case for part 2. We will figure that out, right? We'll figure that out. But I think what we need to do for this is, yeah. So the state is operator. Where do we call the recursion is what I'm wondering, right? We need to call parse again at the top level, so it kind of goes into a recursive state. We need to do that somewhere here, but I don't know where we will trigger that exactly. So I'm gonna just leave that as to do, right? And so if I run this, obviously it'll fail at this to do, right? There it is. And operator. So it's either a literal group or an operator. So once we start processing it as an operator, what do we need to do, right? We process a bit count type. This length and num is going to be a little bit weird, little bit problematic for us. So we have to return either the length or the num, right? But we also need to know whether it's the length or the number, which is what we don't know yet, right? Okay, so maybe we can just do it this way. Maybe we can do it this way. We can call process And we can also set a late init var, right? Or yeah, so late init var is length type. Okay, so I'll just set it as a var actually. Is length type equals false, right? And now what we're going to do is we're going to say is length type equals if bytes of index uh, double equals 1, right? So if it's number of bits, it's so 15-bit number representing the number of bits, 15-bit number representing the number of bits. Oh, wait, so length type ID is 0, then the length in bits. So if it's 0, then true, else false. Let's remove that redundant. Yeah. So is length type is this, okay? And can I do an index plus plus here? So if I do an index plus plus here, I hope it will work. Prefix postfix is that okay? I hope that works, right? So is length type okay? Now what we need to do is if is length type, then in that case bytes of index, okay? Um, Otherwise it's a number type, right? Length or number type. We have two options. So if it's a length type, then we have to read 15 bits, which represents the length of the packet, right? So um, so value, okay, so value equals if is length type, then to do, okay, else to do, right? So let me just remove braces from your statement. Okay, so equals if this to do, else to do, unreachable code. That's fine. So if is length type, then we have to do bytes dot substring index to next 15 bits, it said, right? So index until index plus 15. Oh, I have to add, yeah, because I won't know which one to increment by. Uh, yeah, it's fine. It's fine. Index plus 15 dot to int radix 2 else bytes dot substring index until index plus 11. So that's correct, right? Because we did the same thing here. Index until index plus 3, that gives us like 3 of them plus 11, right? 11 are a number of subpackets, right? Dot 2 int radix would be 2 again, all right? And now what we need to do is index plus equal to if is length type 15 else 11 return value. There we go. Okay, very nice. Now what we have to do here is we have to take in operator. um so operator is currently used here. Okay, no, so operator is currently used here, right? So we have to take this. If it's an operator, then in that case mm, is val is length type equals state dot is length type, right? Okay, or well, we can do it this way, right? So if state dot is length type, then in that case, oh, but we have to process it first, right? We have to call process first. So value value equals state dot process. So it processes the state, goes up by that many bytes or whatever, right? So we know that we've kind of, yeah. So now we are into sort of sub bytes, right? Um, Now if it's a length type, that means we know that next 11 packets or whatever is going to be next 15 bits, right? Or whatever value we've gotten is the length of sub packets, right? Total length in bits of the sub packets contained in this packet. So what we have to do is, um, yeah. So what we have to do is basically this, right? We call parse giving start index as the state dot index. Okay, because it's gone past, yeah, the end of that point. Cool. And this kind of gives us a packet. Okay, so this gives us a packet, and we have to keep going. Basically, we got to keep going, right? uh, I think next when we call finally on an operator, it's just going to be returning terminal, right? Because we'll be done with like processing all the sub stuff. So yeah, packet equals parse state dot index. So it's more like, okay, all right. While index is less than index, uh, no, not index plus. Fuck. Yeah, but basically that, but not that exactly, right? So how we want to do this is where index, I sure hope that index isn't, yeah, it's not really having a problem anywhere else, right? So state dot length type, okay, index, where terminal uh, end equals state dot index plus value, right? Or index plus value less than end. Okay. Um, we kind of have to do that, right? And packet sub packets plus equal to packet, and then finally index equal to packet dot ends at, right? So we do this var end variable is now modified. Oh yeah, this can be changed. This can be set to val, right? So we do that, and finally we want to add. So this is at the end of the loop, right? Sub packets dot add. No, 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 sorry. Sub packets. We've been adding sub packets the entire time. Yeah. And finally, we want to do packet builder dot. Um, wait, did I not create a sub packets thing for it? packet builder ends at literal packet. Okay, yeah, sub packets equals null. Okay, cool. So where sub packets equals. Oh, so this doesn't have to be a list of packet question mark. It can be a list of packet directly, right? Um, equals mutable list of, or it doesn't have to be mutable list of packet, right? And we just put sub packets equals sub packets, and let's can we get rid of the type hints because they're all useless? Remove argument name. Yeah, they're useless pretty much. So I don't think it matters, right? So yeah, okay. Yeah, they're actually useless. Cool. So on the actual implementation, they're kind of useless. All right. Now what we want to do is operator bytes index, type ID. Let me go back here, right? So if operator, we get the value by calling state.process. So we always get state.process first, all right? That's like the first thing we do all the time. Packet builder dot value shift left 4 value plus equal to state.process. Technically, you could have called state.process first and saved its value somewhere, but it doesn't matter because before we do anything else on the state, we want to make sure we call state.process basically, right? So because we have a whole bunch of like state latent vars kind of thing. So yeah, state.isLength type index state. End equals index dot value, index less than end, something something something, packet builder dot ends at, turn packet builder dot build. So we build that packet, we get that, we get its ends at, we update its index. While the index is less than end, we keep doing this, right? We parse the next packet, parse the next packet, parse the next packet. Um, yeah, after we do a whole bunch of those, I think we should be in the terminal states, right? We should be in the terminal states. I think every packet kind of always ends that way, right? Yeah, so I think we should be able to skip it. Skip. Yeah, some stuff. So that's not a problem. Um, yeah, I think we have some data level guarantees that we won't have like broken packets and things like that. So I think that's fine. Override fun next. We need to implement that. Yeah, for now, I think this should work potentially. Type ID is never used, I know that, but that's okay. Uh, okay, so should I just run this? And of course, it'll fail because I think next is not yet implemented. Lot of time. Oh, Java heap space out of memory. That's not what I expected, actually. Mm, so is there like an. So it's definitely in the operator part. Operator value state or process, sub package, mutable list of packet. We call parse. Mm, index equals packet dot ends at. And then finally, wait, so maybe let's implement that as well. Uh, return terminal bytes index. Yeah, because yeah. We need the state to be terminal, right? Yeah, correct. So if we run this now, yeah, it's still gonna have an out of memory. Um, why? Okay, so now let's run the debugger maybe and see what happens, right? So debugger here, okay. So we know it's an operator, right? Ah, fuck. Step out, step over. So we know it's 27. Oh, that's correct, I think, right? Uh, length 27. So we know it's 27 bits that it has to start at, right? And subpackets is mutable list of packet. Okay. State is length type. That's true. Index equals state.index. So index is now 22, right? So I think that's correct because we are done with processing all this. So what's the length of this? Uh, let's see. So scratch. Let's delete that. This dot length, right? What are you? Yeah. So you're 22, right? So we are at index 22. And that's fine. That's perfect, right? We are at index 22, and we should be processing the first packet now, which should be calling in here. Uh, End equals index. Okay. So index is less than end. Packets is parse. So let's step into that, right? So step into. So now state equals version ID. All right. Um, so we are like one level in now, right? And our start index is 22. Okay. So the version ID is where it has to start again, right? So 11 sub packet 110100. So that should be a literal, right? So if I go step in, state is not terminal, state version ID, state next. Okay. So the packet builder should have version ID delegate. Uh, yeah, so that is 6. All right, cool. And if we step over one state, type ID, next. So the type ID should be 4 now. Yeah, there we go. And we go into literal group. Okay. Now value equals packet builder dot value. So the value in our case is null. Oh, okay. Yeah, no, that's true. Null, state dot process, packet builder dot value. Okay. So now we have, so it's 100 and then 0101, right? So that's 101. That is, the value is 0101. That's not 10, is it? Oh, it's 10. It is 10. Okay, wait. Did I misread it? 100 100. Oh, 0. Oh, no. You have to. Yeah. 1010. Okay, sorry. Yeah, that's right. Okay. So at this point, ends at state.process. So it went in terminal wise and 01. And so we should have this length here should be the ends at, all right? So if we go into the scratch file and we do this 33, right? So ends at should be 33. Let's open the debugger again. Where are we right now? Here. And if we go next line, ends at delegate should be 36. That's wrong. Why? Oh, no. Oh, I understood what happened. So it's a sub packet processing terminal skip, right? The terminal skip, which in our case shouldn't have happened at all because the sub packet kind of started. Yeah, so it should compare the length against the start of the packet as such, against the start of the packet. But I don't think it has that information, does it? terminal, because we only pass in bytes comma index, and bytes is the entire string. If we go into terminal, index 4 minus index mod 4. Okay. So we make sure, hmm, is that the problem? Because we are technically ending at 33, but that's because we aren't done processing yet. That's because we aren't done processing yet, right? So we have to figure out for this sub packet call as such where version ID started, we have to keep track from that point and figure out whether we need to skip padding bits or not. So it becomes contextual, basically. It becomes contextual. What I was thinking was, hmm, whenever we reach terminal, but at this point, yeah. It's basically like we have reached a terminal thing with respect to this. So this is exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, what? Is that 11? That doesn't make sense. Yeah, it's 11. Wait, what? So if it's 11, what does that work? 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5. Oh, I see. A sub packet needn't terminate with. Hmm. So should we just not skip padding bits? So are padding bits not going to be there at all for sub packets? Should we just never skip padding bits? I think we should never skip padding bits. We should probably just never skip padding bits. That would be interesting. Process. Should we never skip padding bits? Let's stop this debugger and let's do that on that. Padding skip is not going to be done, which means yeah, replace with a dot call. All right, and version sum. Maybe we just shouldn't check ends at. Let's just run the tests again. Yeah, I think this is gonna have, yeah, it's still having the same problem. Okay, so again, let's run the debugger on this. So, okay, so that was like the first sort of mistake. But okay, so let's see. Value, sub packets, state is length type, end while index less than end. So the index is 22, end is 49, right? So we say that, so we say that the end is 49, which means scratch.kts. This is going to be more, it's 56, right? But this is 49, isn't it? 49, there we go. That's 49. Okay. But once we are done with that, what do we do? Yeah, okay. So we do something. Okay, anyway. So at this point, we want to go down there. We want to go into, step over that. Let's go into again. Cool. So now we are at that state, terminal version ID. We skip type ID. We skip. Now we go into literal group. Um, value equals packet builder dot value. Value is null, value plus equal to state of the process. Now the value is 10, packet builder value, okay, state dot next. Now the state is terminal, so we kind of just go out, right? Um, NZ. So what did packet builder dot NZ get updated with? Um, 33, which is what we expect, right? Given this entire bit, that's what we expect. Day 16 input, no, this one, dot length 33. There we go. So we expect 33. That works out beautifully for us. Let's go back in here and packet builder.build, step over. All right, cool. So that gives us a packet, sub packets plus equal to packet. So sub packets size is 1, index equals 33. Okay. So while it's not yet done, we go in again, step into, step over, step into. So that gives us this packet.builder, state is not terminal, state, version ID, state, type ID, state, literal group, value, value, shift left, value, value. Wait, what? Value is 10 again. Oh, right, right, right. There are two of them. There are two groups, isn't it? There are two groups. So we have 10, step over, state next. Ends that. Why? What? Next should have been. So literal group bytes index equals 1 is terminating as false. It should have been true, right? Of this BBBB thing. 0 1 0 1 0 0 1 1 0 0 0 1 0. Oh, that shouldn't even have been 10. 1 0 0 0. No, no, no. Wait, what? 0 1 0 0 1 0 1 0 0. Okay. 1 0 0 0 1. So that's just 1. And 0 0 1 0 0. So, okay, no, that's. Wait, what? 1 0 100 starts with 1. Yo, Chris, what's up? I'm solving day 16. Getting stuck with an out of memory error on one of the state transitions. I think it's probably going to be like an off by one error or some shit. Day 16 was a beast. Yeah, it's a little bit annoying. It's like I don't know. Like I just feel like they added way too many edge cases and lots of different like okay, yeah, if it's a literal group, it's this, if it's this, if it's this. Like there's just so many cases that it's a little bit frustrating. Took me an hour to understand the problem. Damn. Okay. Yeah, I mean, yeah, I can relate. I can relate. Like it took me a while. It took me a while just to get like what was going on, but I think like the main problem is like it's just it's I don't know how to explain. Like it's not um it's not I I feel like it's not really teaching me anything new, right? Then again, like, yeah, I have sort of structured the code quite nicely for state transitions and things like that. Coding it afterwards wasn't too bad. Yeah, that's the thing. So far, everything has been going very well, and we have been doing it very gradually with tests for every single part, one by one by one, right? So we are building it incrementally as we go along, like test-driven development proper. I would say it teaches you recursion well. Yeah, probably, probably. I don't think the recursion is a problem for me. I'm getting an out of memory error probably because of some kind of off by one error somewhere, but I need to figure out what that is. So if we run this, so now the literal group is somewhere in the first thing, b- and we go here, value, value, value. So the value is 10. That's fine. And if we run this again, this is the second time we are encountering a little group. So at this point, start index is where is start? What is start index? It's 22. Wait, what? It's not supposed to be 22. Oh, that start index. Okay, that's fine. That's fine. Start index is 2022, which means you're on part one. Part two is easy if you solve part one. Yeah, yeah, I know. I expected it wouldn't be too hard. I expect it wouldn't be too hard. Usually, though, these questions aren't like this. Like, I don't know what's up with this year's advent of code, but many of the questions have a part two, which is a very simple increment over part one, and part one is insane for so many of the questions. Like that's little bit unlike how it normally goes, in my opinion. I usually how it is that part one is very fairly limited, and then like part two has you try debugging the sample case and checking the version numbers you print out are right. The version numbers should be fine. I don't think the version numbers will have a problem for me. The version numbers are like the easiest part of it so far. The problem is parsing the rest of the packet. So yeah, I am doing something like that. So I have this now. I'm coding in the operator case. So I've coded in literals. I'm coding in the operator case right now. Yeah. I'm coding the operator case right now, and I'm trying to figure out where it's going wrong because it's going into some sort of like an infinite recursion sort of thing, and like not an infinite recursion, but it's just like never ending. And yeah, all the version numbers, including all the recursive subpackets. Yep, yep, yep. So we have a packet data type which is nested. So it has a subpackage with a list of packet, and by default it'll have nothing, but it can have more than one packet inside it. And so that way, like once we sort of build up the data structure, we should have like everything. So yeah, are you using a global index variable? Sort of. Sort of. I'm not using a global index variable for the recursions. The recursions internally use their own I, I'm using a global overall string. The string is global. Bytes stays as bytes. We never actually change. We don't pass parts of the string anywhere. We always pass the entire string. But the indices themselves are not. It's not a global index. I'm not very comfortable with that. So instead of doing that, like I'm passing in the index everywhere and modifying and returning whatever index I want. So each state maintains its own index, and when the state is created, like for example each state maintains its own index, it updates its own index internally, and it calls the next state with the updated index. That's how it works. That allows me to debug and attach new states, delete existing states without having to worry about the index being transformed, right? So I can always change these transitions pretty easily. So it helps me do that, right? So next, whenever I call next, it just based on the current state, it's able to do it. Yeah. So, oh, this is quite nice. Okay. So right now start index is 22 on this parse call. So 22 means where we at, boy? We are at, wait, so this thing, I'm assuming 22 is still this byte because I think this is like past 33 or something, right? So if we just run this again, uh, what? Oh, I see. That's why we're having a problem. Every time it just goes into literal group and it hasn't updated state.index. Oh, state.index. No wonder. No wonder. No wonder. No wonder. No wonder. Okay. 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 Yeah. 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 Index. There we go. 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 That solves the problem. That solves the problem. Right? Yeah. 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 That happens. Okay. So as I said, yeah, simple typo. I'm pretty sure. I think this should run now perfectly. No, it didn't run perfectly. Expected to, but was 0, which is unexpected. Okay, now let's debug, right? So now let's debug. So I think if we go into this while index less than end, uh, let's mute the other breakpoint. So more, let's delete the other breakpoints. Let's delete, done. Add this back. Uh, let's debug. Okay. So it's at index 22 now. It has to end at like it keeps going till it reaches 49. So we go down, we go inside. That's the state. Okay. So we start at 22. We have this. So packet.builder. So we start building the packet now. State, version ID, yes. Type ID, yes. Literal group. Um, value not equal to null, value shift left, value process. Now the value is 10. Okay, very good. State next. The state is terminal. So we update ends at, and now at this point, subpackets plus equal to packets. So subpacket size is 1. Oh, oh, right. Never mind. I'm stupid. Stupid. I forgot to set this up packets. I created a new line here and I forgot to set this up packets. No wonder. Okay. So, all right. So else there's still a to do. Okay. But that's fine. And now we need to set packet builder dot sub packets equals sub packets. There we go. That solves our problem, right? And that's it. Okay. And now if we run this, we should be having this work. Okay, small typos everywhere. There we go. Fantastic, fantastic. Okay, very cool, very cool. Um, we still need to implement the overall version sum. I have put an at ignore for this test because right now I haven't implemented it. We'll come to that, right? So length type, we have two sub packets. Very fantastic. We have solved that problem. Um, test function given an operator packet of uh, count type, right? So it's not a length type, it's a count type. It's the number of subpackets, right? Uh, then we have how many subpackets? Three, yeah? Three complete subpackets. We have three subpackets, right? There we go. Well, parser equals day16 dot parser of the bytes which we are passing in would be, here's an operator with length ID type 1, right? So that one, cool. Val packet equals parser dot parse, and now assert equals 3 packet dot sub packets dot size, right? There we go. Can we put bytes equal? No, I just kind of want to collapse this, get rid of this variable type explicitly, property explicitly. Let's control XU that, and let's put that there. Yeah, there we go. Okay, so cool. So we parse it, assert equals parser, blah, blah, blah. Okay. And if we run this, obviously that one will fail right now because it goes into this to do, right? Because it's not a length type. Now we have to figure out what to do with it, right? We have to figure out how to implement that. So, yeah. So that's fine, right? We have the else case over here. I later wanted to put this also as a to do, but it's fine for now. Like, it's okay. It's a small change, like, which we wanted to do. We did that. Now we kind of have to implement this else case, right? So else case. So the state is not length type anymore, which means that we have to process it up until the number of times, right? So while I in one to value, right? Val I? No, for I in one to value, right? We have to call sub packets plus equal to packet, uh sorry, passing in. Oh yeah, so we still need to keep track of the index. Actually, we still need to keep track of the index. So can I move this out over here? Equals state dot index, end equals index plus value. Okay, so we still need to keep track of that, and let's do it this way. Let's delete that thing. um so yeah, so for I, oh, so we already did that part. For I in this, um packet val packet equals parse index, right? Sub packets plus equal to packet, and index equals packet dot ends at. So that lets us know when to do the next, how, where to start the next one. Cool. I think that's literally all we'll need to solve that part. Here we go. Fantastic. And one thing I do want to see is I want to expand and see the kit thing. So at this point, let's actually just run the debugger on this while muting all of the breakpoints. Um, more, we have no other breakpoints. Okay, done. So let's debug this. And I kind of want to go all the way till here. And I just want to examine packet, which contains three subpackets, where subpacket 0 is of type ID 4, which is fantastic. It means that it's going to be a literal packet, right? So yeah, and the number should be 1. The value is 1. There we go. It has no more subpackets. The type ID is 4, and the value. Okay, so the version number is fine. I'm confident the version numbers are correct. The value is 2, and last one the value type ID 4, value is 3. PogChamp. All right, cool. So that's enough information for us now to actually not ignore this test and to run everything, and we will see immediately that this one fails, right? The first one. So, oh yeah, I'm very sorry. I should have killed the debugger. Um, should have killed the debugger. That was a mistake. Let's rerun the tests. Yeah, there we go. Right. So now at this point, we can go ahead and implement the top level stuff, right? So version sum. So this is gonna be very, very simple. We're gonna start with val packet equals parser passing in bytes dot parse, right, at 0, right? So that gives a top level packet, and now all we need to do is we need to iterate over that and kind of get, so we need to like sort of dig through the hierarchy, right? And we need to add the version numbers, add up all the version numbers, right? So var version sum equals 0, right? Yeah, we'll keep it to do at the end, so compiler will stop screaming at us. For or for we now need to like sort of step through iterate tree, right? How do you do a, so it would be like a breadth first iteration, I suppose. We can probably just write like on packet. We can write an iterator, right? So packet dot um some shit. We can write like a thing over there, convenience method on packet itself to get you. Hmm, how do we wanna? I just want to iterate over all the packets. Is that too much to ask? I completely forgot how you iterate over a tree. It's just going to be like a breadth first search, except we don't have to mark any visited or anything because we know that it's just a simple recursion, right? I suppose we can do like a version sum, right? Fun version sum, which returns an integer, right, is going to be uh, for packet in sub packets, right? We basically add up. Can we make that one liner? Return version ID plus sub packets dot map it dot version sum dot sum of dot sum. That should work, right? So sum of for an empty will do what? Sum of the all the values. So if I just do a list of int dot sum, or I need to probably have let's open this crash file and test that out, right? So data class it's v int, right? Val v int. Um, list of x dot sum of v it dot v is 0. Okay, nice. So that way, if you take an empty list and you do the sum of, you will get 0. That's beautiful. Good to know. Which makes it a very, very straightforward approach, and we can actually just convert it to an expression body, and we don't even have to put that. What's your problem? Okay, we have to keep that for some reason. Okay, so now that makes it very trivial. We just have to do return parser.bytes.parse.version sum, and that solves our problem for us. Can I convert this into an expression body? I have to keep that. Beautiful. All right. Let's run you. Okay, everything passes. Fantastic. Okay. So test data one, we can try on the other test data as well, version sum of 23 as such. So test function given um wait, so which is the longest one? I will not bother with the others. Operator packet, different length ID contains an operator packet that contains an operator packet. Okay, that's very good. Um, version sum is 31. Okay. Um, and solver equals day 16 dollar input hyphen 2 dot test. Man, this is great. I really like the whole approach we went with here. Solver dot get version sum, and we do need to create day 16 hyphen 2. So uh, if I can just pull that file up in this new file day 16 hyphen 2 dot input, and we can paste that in there. And if we run this, I'm expecting it to pass. Uh, failed. 78. Oh, fuck me. That's a problem. Contains an operator packet that contains an operator packet that contains 5 literal values. It has a version sum of 31. Are we doing the version sum only of... No, we have to do it for operator packets as well, right? Input to... I hope I copied the right one. This one. A00 something. Yeah. Fuck. Okay, so we do have a mistake in that case. I think potentially it's when we have nested operators. It's an operator that contains an operator that contains an operator that contains 5 literal values. So if we look at the parse, if we look at the packet here, get version sum, parser.bytes.parse dot version sum. Can I make this a block body so I can take this thing and control alt v it? Packet, right? Packet.version sum. So can I take this debug here? I hope we don't have any other debugging lines. Yeah, okay. So it got drops here. Packet. So type ID is 0 for this guy. Ends at 22. That's weird. Um, bytes is pretty long. Why do we have an ends at 22? That I don't think should be happening. Subpackets, there are 7 subpackets. That's not good. Mm, type ID is 0, version ID is 5. That's the top level packet that we have already. That's weird. Mm, this has a subpacket. So it says it's an operator that contains an operator that contains an operator that contains 5 literal values. So there are 7 but they should be nested. Okay. So we fucked up somehow. We fucked up somehow. How did we screw this up? Right? Okay, let's see. How long have we been live? 3 hours. What? I can't read it easily. Okay. Yeah, the bot was dead for a while. All right. 3 hours, 32 minutes, 50 seconds. Okay. 3.5 hours. Not bad, not bad. All things considered. We had to write a lot of stuff. Uh, Pretty big problem so far, but yeah. Okay. So, again, I suspect this is some sort of a typo potentially. Um, so it's like 101. So version number should be 5. The type ID is 0. That's correct. NZAT is 22. That's a little bit. That's at the top level packet. NZAT being 22 is a little bit. Uh, how do I say? Problematic. Okay, let's see. Uh, let's see. Let's stop the debugger. Let's start it again with packet builder. State is not terminal when the state is this. So if it's an operator, which it will be, right? Or if it's a literal group, actually, let's put it here and let's put it here, right? So debug, okay. So right now we are still at start index 0, which is fine, right? Value equals state.process. So at this point is length type is true. So it is a length type. Value is 91. So it says it's going to be 91 bytes. Index plus equal to 15. So the index is 22. Return value 91. Okay. So sub packets equals mutable list of packet. Index equals state.index. So the index is 22. Is length type? Yes. It should end at 113. While index is less than n, you're gonna parse. Okay. So we go in. And so our start index is now 22. Okay. So let's sort of resume the program, and that should bring our start index is 22. It is an operator. State.process. So let's step into that. All right. So at this point, index is 28. Yeah, okay. So 22 plus 6, was it? Yes, 22 plus 6, right? Since we're done with processing 6 bytes. Okay. So length type is false. So that's so far correct. It's an operator packet that contains an operator packet. Okay. But we don't know what the operator packets themselves are. Okay. So is length type bytes.substring. Mm, it's not. So the value index plus 11. That is correct, right? So it's either 11 bits or yeah. Mm, so at this point we return value, which is 1. Unbelievable. So it says there's one packet inside it. Okay. So, mhm. Oh, I think I understood the problem. I think I understood the problem. Get the index, okay? At the end of it all, we have to do something with the index, right? We have to say that it is terminal state dot next, but the state this week's lead code contest is the first sponsored one. Interesting. Sponsored by whom? Um, I think I understood what the problem is here. So we get an ends at, right, which we use to sort of iterate over, but we aren't doing anything with the index. We just say packet builder dot sub packets. Uh, that's sort of the problem, isn't it? So if we set an ends at, the problem is the ends at gets overwritten by the terminal operation, but the terminal operation never actually gets this index. Ah, so after we are done processing the operator, we want the terminal. If you do well, you get an Amazon on-site. Oh, interesting. I mean, okay, I guess that's probably that's probably valuable for some people. I I don't. Yeah, exactly, right? Amazon thirsty. Like I feel like I don't like it when companies do shit like this because it's like impressionable kids out of college. Like they have no idea how this sort of shit works, right? And it's like it just feels bad to me all the time. When I see shit like this, it's like this company is just exploiting people's time and efforts, and it's like you may get a chance to sit in an interview, register now, and Amazon may reach out. Notice that they never say they will reach out. They may reach out, right? So even if you get first place, it doesn't matter. They may not reach out to you. So you're getting nothing really from that. But does it have money? Like, do they pay you for it? Like anything? What's the point of the sponsorship? Is the sponsorship literally that you get to sit for an interview? Maybe because that's true with a referral or anything. How does this help? Like, huh? It's like you can just reach out to somebody working in Amazon right now, super easy, and ask them to give you a referral. It's not that hard. Just for fun? Yeah, I suppose, but I just don't like the way they word it. Like it sounds like it's some sponsored contest, right? Amazon will interview most people, exactly. Exactly. They interview everyone, more or less. I mean, not exactly, but it's all like they will give you phone rounds and all that, and those rounds are pretty hard, but for this you get to skip phone screen, but this is harder than the phone screen. This will be harder than the phone screen. The phone screen is not that hard usually. It's pretty hard compared to a lot of other companies, but I'm pretty sure a contest where you have to score like these aren't even this is not real money, right? This is what's this? Lead code points. I see. Well, okay, whatever. It's just a cherry on top. I do lead code contests for fun. I see. Nice, nice, nice. I don't really. That's why I struggle a lot with things like this. But before a bunch of cheaters register, oh yeah, 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 yeah. That will suck. That will suck. Um, okay, what do we need to do here, right? So literal group. No, so I kind of want to call the terminal when we call next with the accurate index, as it were. I think one thing we'll have to do is state.isLength type. Okay, so we'll have to go and modify the index state at the end. Maybe that's what we need to do. Maybe that's what we need to do. That state dot index equals index. So it's like we set it back. We set it back, right? Maybe this will cause our test to pass. did we kill the debugger? No, we didn't. Okay, let's kill the debugger. Run, run. I feel like that's what we need to do. There we go. That's all. That's all we needed to do. Fantastic. So what was happening was, we were taking this index variable and we were POG, right? I know that was easy. So yeah, it was just one part of the thing which was missing was that we were never like after the operator is complete, it would call next and go to a terminal state, right? It would go to a terminal state because it's done processing the operator packet. But the terminal state needs to have the right index to operate on, right? And we didn't have that right index. Now we do. Now we do. We just have to update this. That's all, right? That's it. Okay. Easy shit. Easy clap. All right. Let's go. Okay. Let's solve part one. Solve part one. Um, val parser, no, not parser, sorry. Solver equals day16. The file name is input.prod, so our production input, and now println solver dot get version sum. And now we can probably go back and do that as well. We can make it into a single line. So let me just get rid of all that and all that. Make it return, and then make that an expression body and delete that so that becomes a single line. Yours looks like production code. Yeah, I mean, I just did it very neatly. I wrote like a lot of tests and all that, and yeah, I just made it like as neat as I possibly could because I knew that this question is gonna fuck me in the ass if I don't do it properly because I am very bad at off by one errors. Like index errors, I'm super bad with them. I need to be very careful. That's the reason. That's the reason. Uh, All right, so that returned 1002, which I think should be the answer for us. Um, Bagman, let's go. All right, okay. So now part two. You have the structure of your transmission decoded. You can calculate the value. Good shit. You can calculate the value of the expression it represents. Literal values, type ID 4, represent a single number as described above. The remaining type IDs are more interesting. Some packets, product packets, minimum packets, maximum packets, greater than packets, less than packets, equal to packets. See, it's a good thing, right? It's a good thing that I am actually passing in the type ID. Where's that shit? Where's that shit? Type ID is there. It's just unused right now, right? We're gonna use it in process. We're gonna make sure. Uh, actually, that uh, yeah, we're gonna use it in process. We'll do something, right? So type ID. Actually, we don't need the type ID here, right? Now that I think of it, because like we have the type ID in the packet. We don't need the type ID here because I thought like maybe processing we might need to do differently depending on the thing, but apparently not. So packets with type ID 0 are some packets. Product packets are by multiplying together the values of their sub packets. If they only have a single sub packet, the value is the value of the sub packet. Okay. Minimum packets, maximum packets, greater than packets, less than packets, equal to packets. Okay. You can now work out the value of the outermost packet in your bits transmission, and then we have to, what do you get if you evaluate the expression represented by your hexadecimal encoded bits transmission? Okay, okay. Pretty easy, pretty easy. We can solve this. Um, all we have to do now is, okay, actually, in that case, we don't need this type ID. Let's save delete that, right? Um, because we are storing the type ID already in the outermost, like in the packet itself. So we don't need it at the operation steps. Since it's not modifying the steps, I just wanted to know whether it would have an impact on how we generate the tree in part two. So that's why I did that, but we don't, right? So, okay, so that's good. Now, in that case, the parser is very nice for us. All we need to do is to implement. So let's collapse the parser. We can go to the packet and we can add in a function. Um, with type ID 0, some product minimum maximum greater than less than equal to. All right. Um, so this should be a long, I think, right? So packet value, because product, if we multiply a bunch of packets, then it can get pretty big. Um, right. And we always have more or less always have a value. Can value ever be null at this point? Um, hmm, technically it can, but okay, but for the operator package, if it's null, okay, yeah, I got it. All right, cool. Sounds good. Sounds good. Sounds good. Sounds good. Okay. So fun. All right. So actually, let's write the test first, right? So I think we can do that for test function. So please tell me you have day 16. Wait, one. Do we have a day 16 dot input? No, we don't. We have one and two. 8004. That is not even there in this list. Neither of these two are there in the list. Okay. So let's take the most complex one, right? Produces 1 because 1 plus 3 equals 2 into 2. What? Oh, equal to packet. Oh, hmm. Mm, okay. Have exactly two sub packets. Okay. Type ID 7. Type ID 6 are less than packets. Also have exactly two greater than minimum maximum. Okay, let's encode those rules. Um, all right. So I'm honestly just gonna test with this maybe the minimum packet, I suppose, and the others I'll just assume work. Or should I write tests for each and every one of them? The problem is the way we have made it, we have to create separate files for each one, because unfortunately our read file and process is what is, unless, no, this takes in bytes. It maps from the hex table, it takes in bytes. Read process, read file and process file name. Can we pass in an alternative just to make testing easier? Just to make testing easier, can we pass in an alternative as the direct string instead of passing in the file name? Um, Now that I think of it, I shouldn't have. If I knew it was a single thing, I wouldn't have used this at all. In fact, let's do that. Let's refactor that, right? So Shift F6, Shift Shift F6. I'm gonna call this as the hex, right? So it gets the hex. Read file and process is not what I want to do. So let's go to input one and let's copy that and let's paste that as the test data as such. So that's the hex. The problem is the actual data is like super long, right? Mm, I think I think we can read that from calling read file and process in the test class instead, right? Let's do it that way. Let's do it that way. So input 2.test is should be, so do we are we using day1.test anywhere else? No, we aren't. So input 2 is this one. So let's copy that and we can delete those two files now, which is very nice. Um, let's do it this way, right? So this gives us the hex, and instead of doing a read file and process on the bytes, we can just do hex.map that, right? And we don't need the line or any of the stuff. Um, there we go. Control Alt L. Yeah, okay, cool. So fantastic, right? And technically, I think I can put that directly as Control X. That put remove this from the init block and just put this. See, amazing. Okay, so that works out for us. Join to string. Okay, very nice. So we will have to rerun the tests and just make sure that everything passes still. The only problem is obviously input.prod here, which we will, instead of doing this, we will say val hex equals read file and process, the file name input.prod, um, uh, and given no transformation, what is the data type of hex? So hex, if I put data type of hex is unit or list of unit. Okay. So input.prod it 0. There we go. Fantastic. Cool. So let's just run these, make sure that it still runs. So that way it kind of helps us to write nice little test cases super easily. Oh, beautiful. All right. And that was so fast too. So fast, right? Okay. So now what we want to do is we can actually test a whole bunch of things. So given um, some expression eval sum, right? So given the sum hex, I'll call it sum hex or right. So solver equals day 16, passing in the hex, which is that, right? Assert equals um get bits transmission value, right? So bits value, cool. So that should be equal to 3, yeah? 3 solver dot get bits value, cool. Up, there we go. So let's create that as a member function, get bits value int to do, not yet implemented. And if we run that test right now, obviously it's gonna fail. Mm, sum is 3. Okay, so that's the test. Let's rerun that because the name of the function changed. Of course it fails, right? It says not yet implemented. Cool. Now what we need to do is val packet equals, actually wait, let's leave the to do in there, right? And val packet equals parser of bytes dot parse dot, okay, that gives us the packet. Cool. um we need to get the value from the packet, right? So how we want to implement that is fun get value, all right, or get bits value. He is what? So this is supposed to return an integer for us, right? So if type ID is 0, right? So when expression on the type ID, right? So 0, and we'll have to do here, and else uh okay, so return that, right? So return uh, throw not implemented error, right? So uh, type ID dollar type ID, right? So cool. That gives us, now what do we want to do? Inspect unreachable code option. Yeah, okay, that's fine. But more importantly, I kind of want to yeah, we'll make it an expression body at the end, maybe, if you want, right? So get bits value. If it's 0, it's a sum packet. So that's just gonna be sub packets dot get, no, so dot sum of um it dot get bits value. That's kind of what we want, right? So if we just play that, it should pass. No, it failed. Oh, right. Okay, parser dot parse um dot get bits value. Technically I can just return that, right? Convert that to expression body. Let's delete that, right? And if we run this, it should pass now. No, it failed. Not implemented a type ID 4. Okay, interesting. Why? Uh, 4 is, oh, literal. Of course, yeah, literal I have to keep, right? 4 is just gonna be it's just gonna be value. Uh, non-null asserted because we know it's non-null if it's 4. There we go. Beautiful. All right. So this is going to be in the case of a little packet, right? So sub package dot sum of course, it's going to fail. Like if so, we'll write test for everything. Why not, right? Product given product hex uh, value is what was it? 54, right? Solver equals day 16 of this hex. Assert equals 64 solver dot get bits value, which when we run, it'll obviously fail because it says not implemented type ID 1. So we have to implement that, right? So type ID 1 is product packet. So 1 sub package dot product of. Do we have a product of? Dot. No, we don't. So we have a sum of. We don't have a product of, right? So if it is a single number, then it is the value of the sub packet, right? Okay. Dot fold given an initial r, which is 1, an operation, right, which is an accumulator, which contains an int. So ACC, comma, the packet p is going to be ACC dot times p, right? P dot get bits value. There we go, right? So if we do that and we run this, we should have it pass. It failed. Oh, did I say 64 by accident? Oh, fuck, 54. Okay, cool. That passed now. All right, let's move on to the next one. Um, this one is a minimum packet. Given min packet value is 7. Okay, solver equals day 16. That thing assert equals 7 solver dot get bits value. Boy, I love tests. Tests are so cool. Okay, so there we go. Now it says 2 is not implemented. Beautiful. We can just implement that. 2 sub packets dot min of it dot value. There we go. If we just run this, fast. All right, let's go into the next one. God, I love Kotlin. Um, there's the max given max hex value is, I don't know, 9. 9 solver equals day 16. Given that assert equals 9 solver dot get bits value. Okay, I have a feeling I should change everything to long, but fuck it. Because like the reason I think that is because of the product. The product makes me a little bit nervous. Like whenever we have a product of a whole list of numbers, sometimes it goes above the limit of, maybe should I make it long? Um, get bits value, make it long. If I make it long, uh, has value dot too long. That solves the problem, I think. Yeah, that should solve the problem. So dot fold should be also doing the same thing. Everything should be returning long at this point. Yeah. So if we go ahead 9 and we run this test, it'll fail obviously. Um, and now we just go here and implement it because it says not implemented type ID 3. So obviously 3 is going to be the thing which contains maximum. So 3 sub packets of dot um, max of it dot get bits value, and if we run this again it should pass. There we go. Let's move on to the next one. Test function. This one produces 1 because 5 is less than 15. Okay, so there's a less than packet. Given less than packet, we get 1. Solver equals day 16 of that. Assert equals 1 solver dot get version sum. No, get bits value, bro. Get bits value. Okay, and if we run that, obviously it fails with a not implemented error on type ID 6. Wait, so type ID 6 is a less than. Greater than is okay. Yeah, we will test that as well, right? So 6. Okay, so 6 we are guaranteed at this point 2, right? We are guaranteed exactly 2 subpackets. So I can just say subpacket 0, subpackets 1, right? So um, if subpackets 0 dot get bits value less than subpackets 1 dot get bits value, return 1 else 0. All right, so that returns either 1 else 0. Cool. So 1 if it's less than the value of the second. Cool. And if we run this test, Kaboom, pass, right? Similarly for greater than packet, given greater than hex, value is 1, value is 0, okay? This thing, solver equals day16, that assert equals 0, solver dot get bits value. I recognize at this point like we can just write everything, but I don't mind. I don't mind. Let's do it the nice way. That's so neat. Um, so now we just need to copy paste the same thing. The only thing we need to change is greater than, right? So exactly two sub packets. There we go. And if we run that, that should pass. Fantastic. Um, and finally, um, this one given equals sub packet, um, we get 0. So solver equals day16 of this, assert equals 0, solver dot get version sum. No, get bits value. Sorry. Get bits value. If we do this, it fails because type ID 7 is not implemented, and we just need to implement that. So 7 is it's gonna be the same thing except it's double equals. That's all we need to do, boy. That's all we need to do. And cool. At this point, oh, equals hex actually, not subpacket, right? Yeah, so that's okay. And finally, given nested hex, value is so 1, all right? So solver equals day16, nested hex is this, assert equals 1, solver dot get bits value. Cool. And if I just run this, it will pass because all the rules are present. And at this point, we are ready. Um, let's run all the tests again, just to make sure everything passes instantaneously. Um, and let's do a thing, right? Let's do a thing. This particular thing, which is read file and process, this hex, the prod hex, we will sort of move it out. So control X that, right? Um, and we'll put that as private val hex equals that, right? So private, yeah. So we'll do that so that it kind of, um, yeah, we'll just we'll just have that in there, right? So it kind of executes once at the start of when this class is created, and after that doesn't really execute again. So cool. Again, we have all tests passing, very nice. And finally, test function solve part 2. Solver equals day16 given the hex and println get bits value. Let's run that, and that should be our number. Copy that, paste that in there, and click submit. That's not the right answer. Your answer is too low. Oh, fuck me. All the tests passed. What's the problem? Wait a minute. Solve part 1 has 1002, which is the right answer. But solve part 2 has all tests working, but doesn't work. Why? Okay. Yeah, I should have anticipated that something would go wrong. Okay, let's see. Why is this having a mistake? They're equal, 1 else 0. Um, let's punch a debugger in there. Uh, so this has 53 sub packets. Um, type ID 0, which means we have to do a sum of everything. The answer is too low, it said. Uh, it is problematic. It'll be hard to construct something. It'd be hard to construct something which is the correct version of what we want. We don't even get like a non-implemented error or anything, which I don't think we will anyway. There's like 0 to 7, all the cases. Uh, that's fine, but why are we having an issue? It can't be a typo of some kind, can it? Because if it was, then we would have had. Oh, no, no, no. I understood. 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 So, no, 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 no. What would be the what would be the thing if we have a product packet which has only one thing, or single sub packet, the value is the value of the sub packet. Uh, what if we do a fold on something which has only one, right? Uh, let's see. So let's open the scratch file. Uh, for okay, no, no, no. So list of one dot fold, or list of five dot fold given one acc comma v is acc times v. What do we have? That is 5. So 5 comma 3 should be 15, right? 15. What if it's empty? Sub packets. If they only have a single sub packet, their value is the value of the sub packet. Okay. Maybe we can. So it's definitely a problem with our recursion as such, right? Type ID is 0, which means it's a sum type. Hmm. Four, which is value. Wait, no, 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 sorry. Fuck the version IDs. It's a type ID that I need. Type ID 1, which is a product of two things. Which in itself is What's the problem now? So we've parsed everything correctly. Our issue is that our overall value isn't correct, which is something I find very difficult to believe. Um, so this has a version sum of 31. What if we do this? Uh, test function, whatever, that doesn't matter. Solver equals day 16, given this hex. Assert equals, no, println solver solver dot get bits value. If we run this, what do we get? We got 54 on this guy. Operator that contains 5 literal values. Okay, so if we debug this, um, we should be getting, uh, let's place a cursor here. Let's run it till the cursor. And this guy has, it's a version ID 5. No, sorry, type ID 0. So it's a sum of, there's only one sub packet, which is a sum of one sub packet, which is a sum of 5 subpackets, which are values, all are values, 6 plus 6 plus 12 plus 15 plus 15, 15, 15, 12, 6, and 6. Yeah. So that's 6 plus value is equal to 6. 6 plus 12 plus 15 plus 15 is 54, and that's correct. Man, it's working on all the examples, but it's not working on the actual production sample. That's fucked up. That's problematic. Why? We are so close to solving this question. Why is this value wrong? How do we know what the right value is? Like, there's literally no way of finding this out. It runs instantaneously, but it doesn't run the right answer, apparently. We are using long, right? Because it goes here, that returns a long return when type ID, this stuff. Mm, Value is the minimum of the values of the subpackets, value the maximum of the values greater than. Mhm. Their value. So we always use git. Yeah. What's the problem? Again, let's just be very careful, right? Product type ID 0 are some packets. That's correct. Product package, their value is a result of multiplying together the values of their subpackage. So subpackage dot fold initial one, and we return from the accumulator, comma p, accumulator times p dot get bits value, right? So for every packet, we take the bits value and we multiply it with the accumulator, and that's basically what we return at the end of the day, right? Accumulates a value with initial and applying operation from left to right with the current accumulator value and each element specified initial value if the collection is empty. I don't think we should ever have that edge case, but either way, right? Type ID 2 minimum packets, it dot get bits value. The value is the minimum of the values of the subpackets. Type ID 3 is maximum packets, maximum of the values of subpackets. Type ID 4 is just take it converted long. Type ID 5 is greater than packets. If it's greater than, the value is 1. If the value of the subpacket is greater than the value of the second subpacket, first subpacket is greater than the value of the second subpacket, otherwise the value is 0. These packets always have exactly 2. 6, exactly 2. 7 equal to also have exactly 2. Less, otherwise the value is 0. Less. And type ID 7 is equal to if the value of the first subpacket is equal, otherwise the value is 0. Exactly 2. Maybe it's like a long literal thing. I don't think it should matter, but just in case, right? If we run it 2 for 5 reason. I don't understand. I legitimately do not understand. What are we doing wrong? What is incorrect here? Absolutely nothing. Maybe this needs to be a long? I don't think so. I think it should be fine if it's an integer. There should be no reason for it to be a long value. Shift left 4. Who knows? Who knows? Maybe that's the issue. Maybe that's what's happening. Maybe it's an integer overflow. Mm, Packet builder dot value. Let's let's make it long question mark. Let's see what happens. So of course value here has to be a long question mark as well. Type inference should hopefully make this way easier for us to solve. Let's re-trigger. Let's hope we get a different solution. Oh, we got a different solution. Okay. So it was an integer overflow problem. It was an integer overflow problem. Fantastic. I didn't realize the values go that big. Oh, this goes hard. Holy fuck. Okay. All right. All right. All right. Day 16 done. And that's time. That's wow. That took us a while. That took us a while to solve, but we managed to solve it. Okay, it was an integer overflow. Like everything else, and we don't need the padding skip. I initially thought we needed to skip the padding characters, but if we reach terminal states, we don't care anyway. We don't need to skip padding characters. So yeah, this is the neatest code I've written in my life, by the way. I I write neat code, but it's not normally this neat. This was pretty neat. This was pretty neat. If I had to do like further extractions, I would pull out all of these and kind of make these into its own Day 16 is a full day assignment for most SWAs. Maybe, I don't know. I feel like it's a significantly complex problem. It has a lot of interesting bits and pieces. I made this fun though because I could have gotten extremely frustrated by this question. And initially, the way I had attempted it, the first approach I had for this was completely dog shit and should never be attempted ever. Um, but yeah, day 17 is a bit easier. That's good to know. I'm not going to attempt day 17 now though. It's 2:20 p.m. right now. I think I have a tz command to uh yeah. So that's what time it is right now for me. It's 2:18 a.m. at the moment. Um yeah. It is, yeah. So I've been streaming since I've been streaming for what, over 4 hours now? Um yeah, there we go. So, sometime around 10 when I started. Sometime around 10 p.m. when I started. Code all night at home. Yeah, no, no, no. It's in general, I don't like coding at night because once my mental faculties degrade beyond a certain point, I start writing extremely terrible code. Like what I was doing for day 15 was a very good example of that. I made a lot of very elementary, stupid mistakes. And then I managed to clean it up quite nicely. I managed to clean it up quite nicely. But yeah, it's still not super, super clean, but it's pretty good. Day 16, however, I'm very proud of it. I'm very proud of it. I don't like this question too much. I don't think this question is a great example of a question they should give. I feel like it has too many levels of complexity, and I feel like without Kotlin, I would have literally given up way far back. Like I would have given up a long time ago if I didn't have Kotlin for this question. Like Kotlin made this so easy to write because with sealed classes, the IDE warns me. So I have sealed classes, right? So the IDE warns me if I add another state. So right now I have, let's collapse everything and let's just expand the parser. So you see all these different classes, right? The IDE will warn me if the state um I add another state, like I have all these states, version ID, type ID, operator, literal group, and terminal. If I add another state, like every state that I add, the ID warns me if I don't um have like a case for it over here. It warns me, right? It warns me if I don't have a case for it here. Like for example, if I remove this, it'll actually tell me that I don't have a case here. So there is only one sort of flaw, minor flaw for that, which is that technically state can never be terminal. That's why I have a throw not implemented error here, because state should never be terminal by the time it reaches this point. It should always be non-terminal. That's the only kind of slight problem with that, but otherwise it's great. So I really like the way Kotlin lets me sort of yeah, it's super nice. It tells me when I remove a state or something like that, it lets me know that I haven't handled something, which is really, really good. And it lets me also write some nice little, a couple of abstract things where I can do this, So it's good. It's really good. It's really, really good. Also, I just made literal group long. Wait, hang on. What did I just change the value of as long? I changed it for something, right? The literal group, packet builder value. Oh, I changed the packet builder value. Okay, 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 okay. No wonder. Uh, you interested in working in the US? Your personality is kind of American. I don't know. Uh, like, I'm interested in moving at some point of time soon. But right now, I kind of like where I am at. I don't think it's too bad. I did recently get a promotion. By recently, I mean last week. So yeah, so it's pretty good. Like I intend to make some more kind of changes in the way. Thanks, man. Uh, in the way my team operates and like in general, like there are a few things. Like essentially, given that I'm no longer a junior developer, right? So because of that, like you get a little bit more agency in how you want your team to improve, right? So I'm aiming for some things like that just to kind of get people to improve like software quality in our processes over there and a whole bunch of other things. So I have a whole bunch of ideas. I want to go ahead and try and implement that and like just kind of leave leave the place in like a better state than I found it, right? So that's sort of my main aim, right? So yeah, for the most part, I don't plan to move anywhere right now, but it's possible. It's possible. near future it's possible. Like within a year or something like that. Yeah, I might plan on moving. But yeah, I don't know. Nothing is certain right now. That's just about it. Like right now, all that I want to do is really just improve where I am currently. Although my work is a little bit frustrating in the sense that I don't feel like I'm growing like from a technical perspective. Which is like a problem at a lot of large firms, right? Like you kind of reach this point very quickly where you feel like you aren't really moving ahead from a technical perspective. That's what I want to change, right? So yeah, there are a few things there I think which need to get sort of, you know, which we need to figure out. But yeah, I think for the most part we have. I think it's fun. What I'm doing right now, like especially with all the stuff on the side with streaming, etc. I find this pretty fun. Like it's a good schedule that I have right now. And I don't want to bring big changes at the moment. So yeah, cool. Anyway, day 16 is done. Should I even read day 17? I feel like if I start right now, it'll take me way too long. Here's to 50 stars as AOC. Oh yeah, 100%, 100%. I'm gonna reach 50 stars like for sure this time. Absolutely. Put in your subconscious. Yeah, I think that's a good approach. Okay, let's read day 17. We won't code it though. Actually, I'll do one thing. Let me commit day 16 so that way we can move on with our lives. Get add dot, get s, get commit, hyphen m, day 16, get push, up, get push. There we go. Have you done past years? This is my first year. Okay, last year I did most of it, but I stopped somewhere around day 20. So if you see events, last year's I have 40 stars. I have 40 stars, not all 50. So I did 21. I did only half of 20 because 20 is very messed up. Very, very messed up, this question. Although I feel like if I did another stab at it right now, I'd be able to like solve it. Like, yeah, it's pretty messed up. You have to do a lot of index manipulations. I hate that kind of stuff, but yeah. 22 onwards, I haven't done anything. So that's kind of what I want to do. Like, yeah. But I really like this code. It was driven by tests from start to end. I don't think we deviated from a test-driven um, form at any given point of time, and it's a very good example of how you can actually write production code. Essentially, with the complexity of production code, really, with sort of driving everything by tests. So it's quite nice. Like it's also good that like we have a nice little sort of architecture which allows us to do that. But I think this is like one of those things which makes it a lot easier from our end to just, yeah, like it makes it like way easier for us to actually solve this question. Um, I quite like this. I quite like this. We had it's all string manipulations. Like I remember like I remember one of the people who had in the chat, Godwo had mentioned actually he were the a couple of days ago that like day 16 is a lot of bit manipulations, which I don't think is entirely true. It's not exactly bit manipulations. It's more like it's you can use strings and it runs really fast even with strings. It's not exactly bit manipulation. It's really more of parsing. It's a parser question. So yeah, once I realized that, I kind of went ahead and switched out a lot of the code that I had started with initially. So I had started on a very different approach, which wouldn't have worked, and then I went instead today to, you know, an approach with what do you call it? Finite state automata, basically, which just states going to next states, next. So it's an actual parser at this point. So that's quite nice. I just had to be very very careful about like making sure that my indexes were updated, and as long as that was the case, like I was just being very very careful about that every time process ran, it would update the current index by how many ever we had just processed. So if we process 3 bits, it updates by 3. If we process 5 bits, it updates by 5, and that way I was just being super careful about that, and it worked out. It helped us. So yeah, quite nice. Anyway, let's look at. Oh yeah, these lines got modified. I think it's like a white space change, right? Oh, it's a white space change. Yeah. I just did an auto format. Okay. Might as well commit that again. Get as get commit hyphen am. Thanks, man. Thanks. Thanks for sticking around. I'll just read day 17 and then probably like end the stream. Because I'm not gonna attempt it right now. Uh, Git push. Let's just do that. I'm not gonna definitely not going to solve it right now, but I will read it. All right. Anyway, you finally decode the elves message. Hi, the message says. Okay. Thanks, elves. Very helpful. You continue searching for the slay keys. Ahead of you is what appears to be a large ocean trench. Could the keys have fallen into it? You better send a probe to investigate. The probe launcher on your submarine can fire the probe with any integer velocity in x forward and y upward or downward of negative directions. So x forward and y upward or downward is negative. Okay, so it can fire it. All right. For example, an initial x comma y velocity like 0 comma 10 would fire the probe straight up, while an initial velocity like 10 comma minus 1 would fire the probe forward at a slightly downward angle. All right. The probe's x comma y position starts at 0 comma 0. Then it follows some trajectory by moving in steps. On each step, these changes occur in the following order. The probe's x position increases by its x velocity. The y position increases by its y velocity. Due to drag, the probe's x velocity changes by 1 towards the value 0. That is, it decreases by 1 if it's greater than 0, increases by 1 if it's less than 0, and does not change if it's already 0. Due to gravity, the probe's y velocity decreases by 1. Alright, cool, okay. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within a target area after any step. The submarine computer has already calculated this target area, your puzzle input. For example, target area x equals, okay, it's a range of 20 to 30. Okay. And are these inclusive? I hope it's inclusive. Because if it is, like, we can literally plug this into Kotlin and Kotlin's ranges will take care of it. So that's quite nice. Target area means that you need to find the initial x, y velocity values such that after any step, the probe's x position is at least 20 and at most 30. Yeah, so it's inclusive. Y position and the probe's y position is at least minus 10 and at most minus 5. Okay. Given this target area, one initial velocity that causes the probe to be within the target area after any step is 7,2. Okay, so that's the target area, and this is the source, and we kind of go first step, second step, third step, fourth step, fifth step, sixth step, seventh step. All right. So in this diagram, S is the probe's. Okay, so there's drag, which reduces the x velocity, and then okay, cool, gravity. Okay, this sounds like a physics question. This sounds just like a physics question. I feel like we can solve this easily. Okay. Given this target area, one initial velocity that causes the probe to be within the target area after any step is 7,2. In this diagram, S is the probe's x coordinate, y coordinate, something, something, something. After each step, it's marked. Another initial velocity that causes the probe to be within target area after any step is 6,3. Another is 9,0. That doesn't cause the probe to be within the target area is this. Oh, because it skips past. Ah, I see. Okay. Okay, very interesting. Okay, so we have to look at. So we have to emulate this, I suppose. Okay, let's see. I thought maybe we could plot an equation and then just solve it, right? So if we could do that, but yeah, hmm, maybe we could still do that. I don't know. Let's see. Okay, if you're gonna fire a highly scientific probe out of a super cool probe launcher, you might as well do it with style. How high can you make the probe go while still reaching target area? Yeah, okay. This sounds like a physics question, bro. I don't like these. In the above example, use the initial velocity of 6,9. Using an initial velocity of 6,9 is best you can do, causing the probe to reach a maximum y position of 45. Any higher initial y velocity causes the probe to overshoot the target area entirely. Find the initial velocity that causes the probe to reach the highest y position and still eventually be within the target area after any step. What are the highest y position it reaches on its trajectory? Okay. Mm, okay. Okay. It's solvable. Oh, this is the entirety of the. Okay, that's pretty cool. So, hmm. All right. I mean, it's solvable, but at the same time, it's a little bit annoying, the question. Um, yeah, yeah, it's doable. It's doable. We should be able to do this tomorrow. I think I will do this and problem 18 tomorrow when problem 18 will come out. So tomorrow afternoon around approximately. I don't exactly know when I'll stream yet. A friend of mine is visiting for the weekend. So I'm not entirely sure at what time exactly I'll stream, but it will be at some point during the day. That's pretty much all I can promise you right now. I will fix my plans tomorrow and update on my Discord as usual. So that's that's basically gonna be it. Hopefully my sore throat is gone by tomorrow and I feel a little bit better to talk. Yeah, this was fun. This was I liked this. I mean, I didn't like the question. I liked the implementation. I liked my solution. I think this is easily the best, like quite neat, really neat code that I've written. We can of course extract it into multiple files and stuff like that, which is what I normally do in production. But this is pretty good. This is pretty good, right? We have classes, and it's good. It's good. It's really good. All right, cool. Anyway, so I'll catch you guys on the next one. Pretty fun. We did also have an integer overflow, which is not something I expected. Yeah, learning new things every day. All right. Have fun, guys. I'll see you on the next stream. Bye bye.